Hello everyone, welcome back to my channel again. Today I'm going to show you one of the exploration of the datasets that I have done yesterday. It's about the SMS spam collection dataset, which you can check in Kaggle website. This dataset is about a bunch of labeled SMS message, and it's a good dataset that you can try different algorithm to analyze the spam SMS message. Here you can see the first step is to load the dataset and to check some of the statistical property of the dataset. I want to say it to you first that or the methodology or the check of the different metrics may not be exhaustive. So if you are interested, please use your preferred tool to explore the dataset first. As you can see here, the first thing I want to explore is about its distribution property. So I choose the histogram. But from the histogram, I think I lack some of the information, so I would like to make them together and to see in the later part. As you can see here, when I put them together, it is very obvious that the non-spam, which is called ham message group, is much larger than the spam message group. I do not have the percentage count here. You can try it. But only from here, I think the spam message is a small group and by nature is quite difficult to detect. If we took a look at the density distribution histogram, you can see that basically the non-spam group is very dispersed in a very wide range of the word count, but the spam message are quite concentrated in a relatively small range. Starting from here, I'm going to try different ways to analyze this dataset and to find the best way to classify the spam message from the non-spam message. The first methodology is totally invented by me, which is not based on very rigorous reasoning, but I think the word count would have some meanings for us to categorize these different type of messages. In the process, the key point is to assign several integer values to each word of each message. So give that frequency meaning to the message. So as you can see in the code here, especially this part, actually I'm getting the frequency of the specific word in the specific message and also in the specific group. For example, one word is in the ham message group, and what is the frequency of such word in the ham group. In the end, I'm going to have a so-called 3D data. Is like a vector space that I designed for each single word, which will have 3 dimensions. So I call it 3D data. The 3D data, as you can see in the below part, for each word, I know its position in this specific message. I know the frequency of this word in this message, and I know the frequency of this word in its group. For example, if it's in the spam group, it means the frequency in the spam group. As you can see here, this is a GPT generated summary of this code. If you're interested, you can pause here and check the sequence of this code. So getting to the next stop, we are here to actually further explore the vector space that I created. So basically the idea here is to standardize, to limit the range, the dispersed range of the vector space so that we can have a more standardized calculation. I used the min-max scalar method to actually contain this vector space. So as you can see, the message 1, the first word go, is in position 0 with a frequency in this message as 1. In total specific group, for example, it's a group as a ham or as spam, the count is 10. So these 3 integers are standardized to these float numbers. As you can see here, there are some descriptions for the code above. If you're interested, you can pause here to check. Then let's go to the next part. So basically now I'm going to cluster the message with the k-means cluster methodology and to check if I can correctly cluster the different groups of spam and non-spam messages. And here, as you can see, first of all, we vectorize the message using the standard 3D data, which you have already seen, and then we actually utilize the similarity matrix based on the cosine similarity methodology to actually find the similarity between different messages. So the basic idea is to assume that the spam messages will be very similar and the non-spam messages will be also similar. So it will be easy to separate these groups. So as you can see in the k-means cluster methodology, I set them as two groups and it will fit into this similarity matrix. Then in the end, I have also created this confusion matrix, which you can see the accuracy value is 87%, as you can see before, because we have a huge percentage of the non-spam group. So basically 87% is more or less, as I assume here, is more or less the general percentage of the non-spam message. Because the confusion matrix already shows some problem, I think until this point, the methodology I am trying to apply to this use case is not suitable. In the confusion matrix, the most important part is about the true positive and the true negative. These two parts are very crucial to actually measure if the classification methodology is accurate or not. And of course, we're going to calculate of the recall, precision, and different metrics to compare. In the later models, we're going to see. The same as the previous parts, I show a diagram here about the cosine similarity calculation part and clustering part. And you can also see the print results of some of the vectorized data, and also this is a description of the code I ran before. Then it is also useful to check the distribution of the predicted and also the original label of different data points in a 3D format. Since this methodology already has a very obvious error, I'm not going to go too much detail to it, but just to show you, use Plotly to display in 3D way. In each step, I really suggest you to also check the data frame from time to time to see if the new columns is added correctly and what is the current status of the data frame. So now let's move to the next part. Here I'm trying a logistic regression method to actually redo the classification of the spam and non-spam message using the already vectorized data. And as you can see below, the test precision is 0%, although the train accuracy is 86%, test accuracy is 86%, they are very close. However, you can see that there is no test precision, there is no test recall, and test effort score is 0. So usually these numbers should not be 0. And I also tried to display these prediction results in 3D. As you can see, this predicted the non-spam message and the spam message. So the spam message seems very distinct and very far away from the main group. However, let's see the later part. In here, I tried to actually condense the data into 2 dimensions, which I used the PCA method to make sure that the display of the data will be more easier to be accepted. This general idea is from one of the paper about machine learning in recent days, machine learning and also large language model, and it actually used the PCA to reduce the dimension and to show the data and to see if they are separated. The first graph is about the true spam message group. The second part is about the true non-spam message group. As you can see, if we are in the true spam message group, my intuition is to predict the spam to be a spam. But as you can see here, in this group, most of the messages are identified as non-spam, and only one message is determined as spam. In the later part, of course, I wish all of my prediction will show that the messages are not spam. As you can see here, yes, of course, most of the messages are not spam, but the spam messages, we still have several, which means that these messages are incorrectly identified as spam messages. So let's see. Until here, the previous self-made embedding model was not working very well. So now we are going to try 2 more tests. Both tests are going to be based on the embedding model already existed, and we are going to try both the logistic and the neural network to predict correct label of the messages. So basically, first of all, we need to install the dependencies and check the data frame and so on. And then we're going to introduce the sentence transformer as embedding model. I use this paraphrase mini LLM L6 V2. This is one of the free sentence transformer that I find via ChatGPT. I think it is much sufficient enough for us to explore the current topic. Of course, you can change to a different transformer or embedding model in the future. And basically now we're going to transfer the whole message body to this vector space, which is determined by the embedding model. And we're going to implement a different algorithm, like this one here is logistical regression, and the later one is neural network to predict the correct label. So I'm going to skip to the result parts. As you can see now, all the metrics are non-zero value, which makes much more sense. And let's go through the graphic way to see if the labels are assigned correctly. For example, now if we are going to check the choose by message, we have all these data points in 2 PCA dimension, and you can see the spam message are these blue dots, and the non-spam message are these red dots. So basically the precision is quite well. As you can see here, the training accuracy and also test accuracy are both 98%, which means that the red dot is only around 2% or 1.1% of the spam group. Now let's look at the ham group. So basically the non-spam group, we would expect that most of them are identified as non-spam. And as you can see here, there are only, I think, around 10 different data points are not correctly labeled as non-spam, but they are labeled as spam. So basically the precision of this model is very obvious, it's much better. And as you can see here, when we compare these two models, first of all, I call it a naive model, which the model I just invented or tried, and the improved model is more robust. As you can see here, first of all the metrics are not zero, and the training accuracy, test accuracy are both at a very high level, and for other metrics, I think they're acceptable. Now, I do not further dig into the overfitting or feeding problem, but at this moment, training and test accuracy are quite close. Okay, it might have some overfitting problem because the training accuracy is higher than test accuracy, but this is not our point today. I'm not going to go deeper in it. So below the code description, if you want to check the different step, just pause here and check. So in the next part, I'm going to use the embedding model plus neural network model to predict the correct label. And here I'm using the PyTorch library. The reason I'm using it because our TensorFlow sometimes has different problems. So just to avoid repeating the problem, I choose PyTorch. As you can see, the basic idea are almost the same. We actually separate the train and test data and then implement the different algorithm. And all these parameters are quite standard. So we configure just a very basic neural network and to try it and train it to see if it can get better prediction capability. So as you can see in the later part, I'm going to use also the PCA, 2 PCA dimensions to plot the data points for us to see the result. As you can see during the training, in each epoch, actually the loss value actually change every now and then, and sometimes it can be quite large, but in the end, it's always around zero value. As you can see here, most of the values are close to zero. Then let's take a look at the graphical information. So it's quite obvious that in a spam message group, we have these messages not correctly assigned as a spam, and in the non-spam group, we have only these, I think, 6 messages not correctly assigned as non-span. And if we check back to the training metrics of the model, the train accuracy of this model is 100%. Test accuracy is around 98.74%. I think it's already showing an improvement from the previous model. As you can see here, the model performance comparison, I put them all in the same graph, and you can see the later two models both have much improvements related to the naive vector clustering. So basically, the different embedding models, if you try them, I think you are going to see a different result. From a different point of view, now you can see that embedding models is quite convenient and important to analyze the text information because it gives you more robust or more accurate information about the different text message in our case. And the numerical representation has more statistical meaning than the manually or DIY designed embedding models. I really wish you enjoyed the video today. I wish I have made myself and also made the project very clear, so you do not feel confused. If you have any question, feel free to leave a comment. The video, please do share or like. If you really like the content I create, please subscribe to the channel. So until next time, have a nice day or nice evening, and see you again. Bye bye. Hello everyone, welcome back to my channel again. Today I'm going to share with you one of the test projects I have done recently, which is designed to prompt a large language model with the same question several times and to see how the questions disperse in the space. So basically this idea came to me when, like months ago, in different social media platform, people are discussing about the accuracy of the large language model and about if the RAG flow or some additional design would actually make the large language model more reliable. So I guess this will be a start point to test the large language model. Of course, this is a very basic format, so it cannot match to a very specific use case. But I just wish that this kind of test would give you some idea or inspiration to do further tests on large language model. Basically, the first thing is to install the different packages needed for this test. So I'm not going to go over everything. You can just check by yourself. And the most important thing is that I use Grok because it has a very fast inference response, inference efficiency, and it can save a lot of time. And I also leverage the Google Cloud, the Colab environment to implement this test. Okay, so basically installing all the dependencies using Colab. I also saved my Grok API key here. The Grok API key actually you can get from the Cloud Grok platform. It's very intuitive. You can get it and use it. Then I start by defining, first of all, is calling the Grok model. This is a function. Then there's getting embedding. So it's not very complicated, right? We just prompt the same thing to the model for several times and to see how the response is getting feedback. But you already noticed that here, I did not specify the temperature. I do not have a RAG flow to actually do a test to compare two groups of the different model design and the different answers. So this is a basic model. Like I said, I just want to fast test and see if some of the visuals and the general design works. So we also come down here, you see, to initialize the tokenizer and the model for embeddings. So basically, these models are useful for me to transfer the text information to vectors. Okay, just simply put like this. Then about the main part of the code, first of all, I have the different prompts ready. Okay, these prompts are not designed by me. Okay, so basically, for my personal use case, I never would like to write a short story, like some sci-fi story using LLM. I would like to read somebody's book or check or watch a movie or watch a TV series, but not to talk with a large language model. But I let ChatGPT to design these questions, just to see how it goes. And the number of repetitions, I want to see 10 times of the different responses. So 10 will be the threshold of the for loop. And then you can see we're going to save our embeddings and also the responses, because I also want to see the embeddings. These like the vectorized information for each response, of course we can do further work on it, but to be honest, if the dimension is very high, to actually capture the essence of this information, the best way is to do the dimension reduction, like use principal component analysis, PCA. So when I use PCA as 2, it crushed the vector space to get 2 dimensions. When I crush it with PCA 3, actually all the information is condensed to a 3D space. So in both ways, I'm going to see how they are dispersed. But now I only get a graphical idea. I do not have a measurement of the different distance between these dots. So to actually see a more complex result, more numerical and more robust result analysis, this test is not enough. Okay, we can do many more things. But here, I just prompt, get responses, transfer responses to vector space, show it in 2D space, 3D space. That's it. Okay. So basically in here, the inside for loop is actually to call the model and get response. Okay, and also append the embeddings, those responses. And eventually, I also print some of the information for me to check. But to be honest, if the response is very long and not, let's say, it's not well designed or contained, for example, you want every response to be limited to 500 words, something like this, it's very hard to see the difference, because it takes, if you use your human judgment to evaluate a 500 words long paragraph or a story, one from another, it's really hard. So in that case, I think the embedding results, the vector value results, could be a way for me to understand the distance between the 2 results. But let's see, it only gives you a general idea and nothing more. But I think this could be a good start. So in the later part, you can see there are 2D data and 3D data to actually print them in 2D and 3D space. For me, really, generally speaking, I think because our limitation of understanding the graphical information, 2D and 3D space are the maximum, because visually we cannot, for me at least, I do not understand how to represent this 4D space. Maybe from a sequential 3D space, or from some other representations that requires more profound understanding of data and machine learning and so on. So let's see. So basically, the first question is to ask the large language model to write a short story about time-traveling cat who visits ancient Egypt and befriends a pharaoh. It's very nice prompt, I see. And you can see the large language model without setting any parameters. It's very creative, and it actually created a short story. So I'm not going to go to the detail. If you want, you can check and get a sense of it. But to really understand and interpret it by human for several chunks, documents with very long length, it's really time consuming. So I'm going to jump to the second part of the embedding, and you see to transfer this whole passage to embedding. to the vector space. It's very complicated. See, it's very long, a long list of numbers. And for a response, so I print only 5. So let's see. For the first question, we get all this response. We can see that some of the responses are very close to each other. So, which means that let's see the general pattern large language model. We can actually summarize to different categories. It's like this one is the main part in the middle, and the others are outliers. But you see, if you do not contain the large language model, either using RAG, either using chain of thoughts, there are many different tools to implement the tool calling and different methods to make sure large language model is more reliable. Without those tools, the results you see from a large language model are very dispersed in the vector representation, or in the 2D space, in the 3D space. So as you can see, just intuitively we'll understand that there are some outliers and some of the responses are very concentrated, right? So if you change the temperature, if you change how the large language model is getting a response, results are going to change. So based on my understanding now in the market, there are some people who like to use large language model for enterprise use case. So even for query like a large language model to query language like a SQL, its reliability is key. So in a very specific use case, the accuracy should be 100%, because you don't want the large language model to go play with the whole workflow and generate a very simple query, with error. Like I want to query company A 2022 net profit. It should be a fixed number, because that's it. It should not be ambiguous. So in this case, after seeing these results, I think with or without a very robust RAG flow, I think no matter what is your use case, first of all, you need to identify the accuracy requirements. For example, if you just want to get inspired, of course, you can let the answers fly. But if you want a specific query, like a SQL query, the result should be very accurate. So this kind of test, I think, could give us some idea. So basically, based on this 2D representation, you can do clustering, you can analyze dispersion, and if you really have large computer resources, you can actually test many times to see the dispersion. So this idea is actually partially inspired by one of the paper to discuss the different response. I think malicious response from large language model and their dispersion. So basically in that paper, eventually it has to crush this huge list of number to 2 dimensions, 3 dimension, to let us understand, to better get a sense of how the responses are dispersed in the space. And following the PCA 2-dimension graph, I also simulated randomly some of the number to give you a sense that if the results are really random, actually the dispersion in the 2-dimensional space is more dispersed through the space. This is only for showing the idea, but it's not related to the test data. Then here, this is a 3D vector graph that is simulated by the random number. So as we can see, if we are seeing a really random result distribution, the points are very different and dispersed in the 3D space. So based on this, we have an expectation that the large language model should have a not so well clustered results. So let's see the next part. For the other question and response, of course, you can check, but the general idea is that we get a response to the vector, map it to the space, and to get to random vector sets to let you get the idea how the really random numbers could be. So now we go to the dynamic 3D display part. Of course, we use Plotly package, and we now crush our data to a 3D space. So in this part, I do not show the textual results, because I think the 3D graph should give us the idea. So basically, each question has got 10 responses for large language model. This is the first one, and this is the second prompt, and this is the third prompt. As we can see, if we actually make our space into another dimension, the distribution is how can I say, is more dispersed through the space. You see, there are not. Yeah, you see in the middle, maybe there are some points that's very close for specific prompts, but in general, it is more dispersed in the 3D space. And we can see that for a different prompt, which got generated different responses, they could potentially get very close. So this is very interesting. It really encourages me to do more tests about a specific use case to actually understand how these responses are dispersed. So basically, without dig deeper to the training, to the building of large language model, or fine-tuning to make it more accurate, or to add additional workflow to it, after this test, one thing is for sure. I think to understand the large language model's answer distribution, the best way is to test with a very specific question and see how they dispersed. But I think only relying on the embeddings, there are maybe some of the semantic information or meanings, different textual information you cannot capture. So I also doubt that if the distance is this far away, does it really mean these two answers are really different? So we need to find more ways to actually get the insight of the differences of the different data points. Okay, that's all for today. So today I have showed you test I have done is to actually prompt a large language model to get a series of responses and use the embedding model to transfer them to high dimension vector space vector and to crush it to 2-dimension or 3-dimension. Okay, so you can see the difference of different response. So based on this, it will give you a good start to get deeper understanding of large language model, especially if you are like me, who is very interested to understand how the large language model perform. I think this is most intuitive way. When you actually go deeper to go to like the fine-tuning and different workflow design, it will create more, the more chance for you to better utilize large language model, but you need to test it. Even with RAG, like one of the products is called Perplexity, I remember. It is actually very famous for its RAG flow. I think it actually falsely puts all the citations to each answer generated by the platform. But even that kind of software can hallucinate. One day I just asked a very simple coding question. It actually gets to a very simple loop. So this really makes me think, if a large language model cannot be always 100%, using different combination of tools, we always need to understand, to test, and also to, if you are using it in your production case, always make a good ledger of all the results generated. That's very important for you to keep track of the performance, how you choose the model, how you fine-tune the model, how you build a RAG flow. And so recommendation to all the audience, do some tests and see how the large language model works. See you next time. Bye-bye. Hello everyone, welcome back to my channel again. Today I'm going to share with you 4 very frequent or very popular cases for the machine learning. And these 4 cases can be easily linked to the scale-up case, which means if you successfully handles a small portion of the data set, it is optional, and it is also encouraged that you utilize a more advanced algorithm, like with the Spark handling of the data set, to actually calculate a larger portion of the data set. So basically today I'm going to show you some basic steps to analyze these documents and the possible solutions for the next step. Okay, so today is a quick overview over the 4 cases that you might meet in the machine learning study process. So the first one is finding similar item. The setup of the Kaggle API and also the secret in the Colab, you can check a relevant instructions. I think in Colab web page, it is also clear that you can set up the different parameter to facilitate your quoting of such a resource. So you don't need to type into the information every time you utilize this functionality of Kaggle API. And the dataset we're going to use is this one, LinkedIn jobs and skills. So basically, we're going to use 2 parts. One file is called LinkedIn job, and let's go to see it. This first one is called job summary. So basically, this one is about a job link and a job summary. I do not print the data frame details or statistical information here. If you are interested, you can do so. So I'm going to focus on the very shortened process. So basically, since this data set is very large, I sample 1,000 data points from this data set. So basically, they have 2 columns. The first column is links, the second column is job summary. And then we may utilize the vectorization method of the summaries. Basically, it just transfer these textual information into the vector space, the vector values for your further processing. If you want to go to more details, make a comment, let me know. I can go to details to explain to you. And then we can calculate the cosine similarity. So basically, this is one of the way to calculate the similarity of the different text information after they are vectorized. Okay, so you can also find the different ways, like Euclidean distance. So like Euclidean distance, you can somewhat transfer it to a similarity case, because the longer the distance, you are going to say these values are largely different. The closer they are, the less the value of the distance. You can see they are more similar. And of course, you can also use some of the other algorithm to see the overlapping of the shingles or the tokens that you set for the textual information. You can use that also to compare. Of course, that one is called Jacquard similarity. So you have so many options here. So if you want to expand this part, you can use different algorithm and compare their difference. But to be honest, at this moment, a pure numerical comparison sometimes cannot catch up the semantic information contained inside. So later, I will show you some of the print results to explain you what I mean. Then about finding the similar job summaries. Usually you can set a threshold, right? A threshold like 0.8 is what I think is a threshold to say they are similar pairs. Okay, this is to find the similar pairs of jobs and save the similar pairs information. And eventually the print of the similar pairs is just to print the similar jobs. So I'm going to show you several. Show you just one. Okay, so to save the time, the first one is job 4 and job 48 are similar with score 1.0. So basically it says that these 2 jobs are largely similar or a potential duplication. Let's just see. This is love your job at Texas Roadhouse. Okay, and to be a grill master. Okay, I guess these are the 2 most important information for me to read this text at this point. Then let's see what it says. Job 84. Let's see. Yeah, it's job 84. Job Texas Roadhouse, right? Grill master. Okay. So after this quick check, I get an idea. This is potentially a correct answer. It has found some duplication, and of course you can go on and on to check the others. So basically, the similar job search, you can use it in many ways. For example, if you want to detect the duplication or similarity pairs of the data sets, or whenever a user of the LinkedIn, the user uses this platform to search for a job, on the other side of the page, it can show a similar job. So just to guide this user to another potential candidacy possibility. So these are the ways that they can be used. Of course, you can also implement and improvise many other use to use these pairs of jobs that you found. So there are also other examples. If you're interested, you can check. And then let's check about the cosine similarity distribution. I think the pairwise similarity, the best way to visualize is by the heat map. Okay, so you just use a heat map to see which pairs are less similar and which pairs are highly similar or even duplication. As you can see, we see very few red dots, so which means that red dot or orange dots, so which means that the duplication or the largely similar pairs are less than the blue ones, the less similar ones. The other way to go into this visualization is to partition or set a section-wise partition to investigate in more details. So here we just see a very macro level summary, and if like here, I actually separate them to different ranges. You can see this is from 0 to 0.25. So you can see this is one part of the similarity information, and then we go to 0.25 to 0.5 and so on. So by separating them to different range, you can see basically if we are going to find a high similarity pairs, actually the data frame, the data set has been shrinked to a much smaller subset, so you can work on. By these visuals, it can give you some idea how you can move to the next step. Then let's check the second project. It's called market basket analysis. So basically, the project is to find, let me show the result first, find the specific rules to interpret the different keywords, let's say. For example, like this rule number 1 is saying that if a job requires leadership, there is a 62% chance it also requires communication. Okay, so this is a way to find the possible information connections between the different data points and give you a sense, like in this case, where some of the keywords are highly relevant to each other. And you can also see here communication is 2.13 times more likely to occur with leadership. Okay, so these are kind of information that you need to use to analyze the data set. So here, as I said, this data frame could be potentially very large. The best way for you to start with a Panda data frame, Panda package to analyze the data. It can offer you many versatile tools to calculate, to visualize. But the most important thing is that to remember, you don't want it to explode your memory budget. Like in Colab, your memory is fixed. Your local machine can handle a fixed size of the data simultaneously. So without using additional large-scale calculation package or methods or database methodologies, the best way now is to sample. Okay, always recommend this. So you can also do some data cleaning that is optional. But if you want to do more, you can clean also the special character and so on, right? And here is to convert the job skills column to a list of unique values. Then we use one-hot encoding method to create the data frame. And there is also a step to apply a priori algorithm. So basically, after implementing this algorithm, you can print out the association rules. Okay, and of course, if you want to go more detail, you can adjust the parameter, check the documentation, check the methodology description to understand it better. Okay, and eventually we see here are the rules, right? The rules are printed with numerical values. This is one thing that I like about most of the outputs of any algorithm, because you can interpret the numbers in a more direct way. So let's see some of the explanation here. It actually explains each column like if, okay, the first column says if, like this one, if leadership, then communication. Okay, and then the proportion of transactions that contain the if part, okay, antecedent supports and also consequent supports. Okay, you can check the details here. But eventually, if you map it to each detail case, it actually means that if a piece of information requires a keyword, there is how much chance that it would also require, okay, another keyword, okay, about the coincidence. And about the lift is like odd ratio, I guess, about how many times more likely. Okay, so this is a second project. The third one is about the link analysis. Actually, I want to utilize a data frame where we can have the different links of a art piece and to analyze the link relationship there. However, that data set in Kaggle is not working very well, and I have not been successfully downloading that data. So now I choose another data. So this one is called Karate Club graph. Okay, so just worth mentioning, for either you want to analyze a bunch of URL link and their relationship, or this one, the basic thing is that you need to understand the data frame should have nodes and edges. Okay, these are two most basic ones. Basically, each node's representation, like this one is representing a member of the karate club, and the edge representing a friendship between the club members or relationships, right? An edge between two nodes indicate that the two members are friends, or even you can define a different type of edges. Okay. And there is also a split. I think it's in default for this specific data set because it's for test purpose. Yeah, they are actually split to factions, right? So you can check the different rules of different data sets. Then let's go to the analysis of the different methodologies. First one is a function to implement page rank. Okay, so a page rank is actually utilizing this algorithm, calculate, and eventually return this nodes and page rank information okay, back to the function. So basically we actually use page rank, this function, directly on this data set. Okay, and we need to convert these data frame, because the original data frame that is not like a table, to put it simple. And here we actually transfer it to data frame. It's like a table, so we can better analyze it. If we display the first 10 nodes, we can see here. Okay, so one node with one node is PageRank as how much value, right? So basically, you can view it as kind of importance of this page. Then visualize the PageRank as node size. Okay, so just to show its importance, and here we have the graph. So basically, we can see 0, 33, 32 are the biggest nodes, and it actually connected to all the other nodes in different ways. And all the edges, all the lines are showing a relationship. Okay, so how can we interpret this? So PageRank values output. PageRank values in the output represent the importance of influence of each node in the network. Higher PageRank values indicate more influential nodes. Okay, so basically, node 33 has the highest influence with the PageRank over this value, and so on. So in summary, node 33 is the most central and influential node in the club. So we can interpret it in different ways. For example, like in the social network, okay, in a social network platform, if they find using this type of way to find several people in a hypothetical group of people, users, and this center person is very important, we can actually implement some algorithm. For example, your strategy of of the advertisement, your strategy of marketing could potentially change, because once you get the attention of the central person, this central person can share or can spread this information in a faster way than the other persons. So they are kind of identify the key personnel in your user base. Okay, this is one type of the interpretation. It may not be very robust, but it can give you some initial idea. And we can also see here, okay, node influence, node with higher rank page scores are considered more influential, more important in the network. Okay, and also we can see the network centrality. So to find the most important node, you can have different ways to handle such information. The last one is about a plant leaf recognizer. To put it simply, it is an image recognizer problem. So for image recognition, I think we have so many existing tools in TensorFlow, and also to classify these photos. I think it's always a very interesting task, because classifying the photo, I believe it can also extend to other calculation or algorithm about images. Okay, it's like object detection, different ways in machine learning, or automatic driving, and so on. I suppose I have not yet touched the automatic driving part, but yeah, here we are. Let's see how it goes. So basically, this is a data frame I found. It's like flower photos. Okay, so basically, the first thing you need to do is to extract this data, right? So basically, extract this data and create a generator. Okay, this image data generator is actually directly using the TensorFlow package. Okay, so if you want to go to more details, I can also do another video to explain you how this in detail works. So basically, it actually needs you to set up different parameters, okay, according to your needs. Then you can set up the train data generator, okay, and also the validation data generator. So basically, it's like any machine learning model. You can set training set, validation set, test set, and so on. So here I do not set the test set, but I have the training and the validation, okay, to do the basic calculation and to see how the loss and also the accuracy evolves. Then I build the model. with the mobile net v2. This is a specific model for image classification. And the model use here the base model, then like the global average pooling 2D. Okay, these are different parameters set to the model. Okay, so basically, if you are using a neural net, is a different story. You need to set different types of parameters, function names inside. Okay, so here is also the layer. Okay, and the activation function is value, and also there is also a dense layer about generating the number of classes, and the activation function is softmax. Because in general, the eventual target is to classify, to tell you if this flower is this flower or another type of flower. And when we come to the compilation of this model, like the optimizer, loss function, matrix, these are all parameters we need to set here to determine how you run this model and get the result. I can debug quickly, but it's optional, right? You can change to link with your language model API, okay, with Llama, with LLM Studio. It's optional. Okay, you can choose based on your use case and your preference. So here I use LLM Studio to load the model and be ready. And after the assistance of large language model, I created two applications based on Gladio framework. You can see here is the chatbot and the chatbot 1. The difference is that the chatbot version is totally based on the creation of ChatGPT and some manual modification to improve the code and to debug it. The second one is based on the creation of Claude. Okay, Claude. This is also a very popular platform now. But later you are going to see there are some difference. And without going to the detail of the code, first of all, let me tell you how they look like. On the right-hand side, the first page is the LLM Studio chatbot. The name, of course, is you can name it whatever you want. This one is created by ChatGPT. Okay, so my first prompt is to code to show chosen SP500 stock price trend with chosen time horizon. It actually produced the code, okay, and the answer seems right. You can try the code. If the code is not working, of course, you can iterate the discussion with the model. And on the right-hand side, you can see this is a different kind of design, okay? So the prompts I used to ask the language model are basically very close, except that in cloud environment, I ask it to add some features. First of all, I want to improvement of the UI, user interface, to look better. Second, I want to see the code output. Of course, this is just a test. I know that in order to run the code, you need an environment, you need a lot of things to be set up. Simply on the browser, it just does not work. But eventually, I just want to see how it designs the interface. So let's come back to the left-hand side. So basically, their proposal of the code, okay, the structure, similar, okay, from the GPT model, from the Claude model. Let's see the GPT-1 first. Okay, so the basic setting follows the design of LLM Studio. Okay, how to call the client, how to send the system message, and there is also the function to actually chat with the LLM Studio. Okay, as simple as that. So a good thing with LLM Studio locally is that you do not need to mandatorily fix your model. Okay, you change the model you load in the LLM Studio app. You don't need to change the code. It is adaptable. You just call it whenever you want with the model you already loaded in LLM Studio. Okay, and then like the Gladio chat interface part is very simple, just several lines of code. Okay, so I think after you learn more about Gladio, you can of course change it, like the UI, like the functionality, and so on. Okay, pay attention to the right hand side, because at this moment I only tried to submit the prompt and get a result. Okay, like undo, retry, clear. Retry already tested, it is okay, but like undo and clear, for example, if you already if you already prompt the large language model, I think it's quite impossible to undo the prompt. So basically, I think the undo and clear are very similar. Okay, it's just to clear your user interface, because once you prompt the large language model, the record is there. If you see the verbose log, you are going to see everything. Okay, let's see the Claude version. It actually incorporated more modules, okay, and of course in the first part it actually preferred to do the configuration, okay, which is quite different from the GPT version. It actually set up all these system variables. Okay, either you are using Colab or in local environments. Okay, in some cases it's quite convenient to set the system variable in the beginning, and the format of the history, like the functions are more, right? It's not just the chat with the Studio. The chat part, the function are almost always similar. However, you ask the large language model to produce, and it has more functions, right? Like handle the history, execute the code, and to process the message. And this is the interface. You can see now the interface has more details, which make it look better. Yeah, I think to work on the interface, you can work on this part of code and to improve it. And now I really have a problem about the execution of the code. Okay, it actually gave me this part to execute the code. Okay, but it is not successful. So I guess in the future projects, this should be what I work on. Okay, I either to bridge the code generated with some environments and let it produce results. So this is the code and this is the result. Okay, so basically you see, I think from my point of view, I think the right hand side UI is more organized than the left hand side. Of course, if you break down to different windows and you need to check the different elements if their layout is meeting your demands. Okay. However, I still think the right hand side seems the fonts are bigger, and you see there's highlights of the window title, right? And of course, there's an option that you can actually change the window size to display. Okay. And on the left hand side, it's kind of rigid, the design. Yeah, but for the prompt box, of course, you can change. Okay, these are just some details you can explore later. So basically today, I just want to show you that if you want to build a local user environment, user interface to interact with your local models, Gladio is a very good choice. You can try it out. If you have any problem, if you want to discuss anything, feel free to leave a comment. And see you next time. Bye bye. Hello everyone, welcome back to my channel. Today I'm going to share with you one of the projects I have done from the beginning of July. Now I have some intermediary results, so I want to share with you. So basically this project is based on the framework of nested chat published by AutoGen. So basically if you go to AutoGen documentation and you check this nested chat page, it will describe to you how the different scenario works with the orchestration of the nested chat. So if you are interested, you can go over the whole documents, see how it performs. One thing I would like to mention is that because most of the AutoGen example and the results are run based on the backend of GPT-4 model, so its results may be quite different from the open source models. I'm not arbitrarily define the open source model as inferior, because there are many benchmarks, as you can see in different social media channel and also the HuggingFace. For example, you can see there are a lot of analysis saying that the open source model is approaching to the level of answer precision and different benchmark. They are going to approach the closed source model. However, in my use case, I still find that there are some gaps. So now let's read the summarization from ChatGPT. Actually, this framework nested chat refers to the process where a receiver agent, after receiving a message from sender agent, may initiate multiple internal chats with other agents. Okay, I'm just going to stop here because in my understanding, it is actually, for example, if we have several agents talking in a round table, it's like several people have a meeting. Okay, you have different ways to organize, like a sequence to ask who to speak first, who to answer first, and how to go back and forth, and how many rounds of chat you want. In this case, nested chat is like you have a smaller subgroup. Okay, it's a subgroup structure where you can refine the answer before present to the user proxy or to the for us to see. Okay, so there are some examples. I prefer to read the official documentation, but from here you can see a very shortened, okay, very summarized information. You see, you need to define the task. Of course, you need to define the agents, right? And the most important part is the user proxy register nested chat. This is the key part of the chat orchestration. Okay, so it's not like in the other example that you initiate a chat. This one is actually to register nested chat. So the package or the program will understand how to orchestrate this nested chat. So like you ask the agent to write a story for you, it will have a critic in the nested chat. So critic will critique it and also improve the writing with the writer and then present you the final result. Yeah. But of course, as you can see here, if you want to expand, want to have more complicated, complex, nested chat structure, you can do that. But I would suggest that when you handle the package like AutoGen, just do gradual improvements or gradual modification. Later, I'm going to show you some of the journeys, some of the experience I had during this period of developing. Now we are back to the VS Code interface. You can see some similarity with my previous projects. Basically, we have the app Python file as a main program file to actually execute the very important execution sentences and to organize the workflow. And we also have the agents file. We have also the configuration file. The API key, I just use a random number to hide the actual API key I use. I'm using Grok as backend because such a program, when you test it, the speed of the backend is quite essential. Okay, you cannot just, for example, my local machine is very slow. I cannot wait 2 or 3 hours just to see a group chat results. Okay, I mean, if it becomes very complicated, take several minutes, even 10 minutes. Okay, and the most complicated case where I let a local large language model to run continuously, and it is a relatively big model. It can take 2 or 3 hours. So the suggestion is that if you want to experiment some of the projects, Grok is a good option because it's really fast. But pay attention, most of the models are quantized model. It is, for me, I understand it as a shrinked model. So of course, it has limited capability than the complete model. Okay. Then I also have the workflow Python file to actually define some of the workflow. Okay. In here, there, of course, if you want to separate it, put it here is okay, or you can just put it in the app.py file. Okay. So let's go back to C. So I'm going to explain mainly on this part. So basically, first part is importing the different packages. Then we define the task. The reason I'm writing some of the predefined task is sometimes I want a quick test without manually input a lot of information. Okay, you can input your prompt however you want. Okay, there is also an option. And then I show this markdown in the page. Of course, now because I add some of the explanation sentences here, you're going to see in the app page, but when you delete, it will be fine. So we also have some sidebar functions to let's choose a model and do a lot of things. So basically, you can also choose the temperature if you set it correctly. Okay, as I said, if you want to interact with the large language model to improve your code writing, it's better to gradually increase the complexity of your program. So like now, I have not done all the tests necessary to make sure that my application is robust, which means are all the functions called, are all the variables called, are all the lists correctly set up. So eventually, if you want to have a very robust program, you need to check a lot of things, test a lot of things, okay? So that's what I suggest you to do. For example, now I might have some error, okay? Most of the contents are generated by a large language model. Of course, I get it step by step. I change some variable, change some sentence. But in general, if you want to publish it, if you want to present this project, please do more checking and test. And of course, there are some additional steps, but here I'm going to say the first important part is to create the agent. So agent has different definitions, have different functions. You always need to define it. Okay, so one way to do this, I can put the documentation description into large language model, say what I want, ask the model to give me feedback of the code. But this code may have some problem. For example, some of the functions are not called. We have some idle sentences. Okay, these such kind of thing are not good for your program. Okay. Then we have the button like the how we initialize this nested chat. Okay, and here for the graphical chats is the chat I really want that the program can do for me. So to provide me with additional graph, financial analysis, and peer review. So far, this part does not work as what I want. So basically, there are some issues here. So if the agent gets the code correctly, it can run the code. But to display the graph in the Streamlit interface, I cannot resolve this problem. I cannot display it. Okay, this is a problem I left for the future projects. The other thing is that if you want, like I said, the complete in the example, official example is to draft some of the reports and to iterate, use large language model as a critique. So as a critique, I mean it could be like if I'm a person, it's very subjective, right? I can talk, even without some of the fundamental base to back my opinion. So in the official example, you cannot see a lot of variations of the execution of the program. But when you, like my example, I go to production, I will see a lot of issues. For example, I would like to say, okay, nested chat has the main purpose actually to get the stock information, analyze, write a report. Okay, then I wanted to get the graphical information, financial information, and also do some peer comparison. Okay, it's not very okay. So like I said, one step forward to increase the complexity of the program. I think it requires more expertise over the programming language. So that's what I'm going to improve. Eventually, we have the result processing. Okay, result processing like the summary and output and so on. Yeah, you are going to see the results later. Then you can see here display financial visualization, conversation history. Mainly the financial visualization, this part is the most difficult part. I have not yet resolved the issue. Okay, for conversation history, and also the chat of the summary, we are going to check later. Okay, so now I'm going to review one of the chat detail and also the result with you. for this one, actually, I ask the application to analyze 3 random SP500 report stock and to show me the analytical results. Okay, so basically this is what I get from the app, okay, from the web page. And I can see it's a very comprehensive report. You see the title is okay, unveiling financial landscape, 3 of the SP500 stock analyzed. Okay, so it says it picked Nvidia, Microsoft, or Disney. Okay, so because my prompt, if I remember correctly, is not very complicated and does not have many constraints. The main thing I would ask it to remember is that today is September 6, 2024, and please show the citations, show where you get the data. Okay, so from this report, you will say, okay, this model has this chart has given me some very useful information. But if you look closely, I already examined some of the data. They are all wrong. This is the hallucination results. Okay, and you see, especially in the citation part, is general citation. It's like the model makes it up. Okay, so if, for example, for serious matters like financial analysis, if you have the wrong data, basically it's useless. And let's see the chat result. So basically, the framework will start the chat and chat manager. The first assistant will start the work. Okay, this is my prompt. Okay, analyze 3 random chosen stock in SP500. I want the price, financial, market sentiment, show sources if you say anything, show dates of all data, use latest data available, today is which day. Okay, so my prompt is quite complicated. Of course, in my program, it cannot decipher this task. If you see my previous video, we have it's called agent chat. I remember is you have the free tier and the paid tier usage possibility for that tool. I have tried before. It actually has a very good framework to decipher your task, separate to smaller tasks. So it could be an improvement in the future. But let's see. So basically, the inner assistant starts to work. Okay. So inner assistant, based on this task you gave it, it actually starts to write code, execute code, and so on. Okay. But you see, whenever I see this program actually touch some API key, I know it's a dead end because large language model know some of the successful data retrieving method is to link to an API and get financial data. But this API, if never offered by me, okay, in any of the agent chat, it will not get the necessary information because it cannot just make up this API key. So whenever I see this API key, I know this chat will most likely give a failure results. Okay, so actually as it goes on, you can see, all the steps are described very comprehensively. You see even the sentiment analysis, right? Okay, and let's run the code. And also error fixing, okay, also mentioned. So by this step, it actually stopped. Okay, and there is a new chat directly to polish the content and make an engaging and nicely formatted blog post. Okay, so this part is actually directly citing the official documents of AutoGen of Nested Chat. So the assistant actually still acts as a report writer. Okay, so here it does not get any information, any true information that we needed. So it continues to do the job. Okay, so you can see this is actually useless because all the data are fake. Okay, so then the writer continues to say, okay, now we write this report. Okay, until here, and we see a reviewer. They basically just continue to repeat the things again and again. So there is basically no improvements. And you see there is also a reviewer to review the compliance. Okay, the compliance is a quite broad concept because if you are going to say compliance, it depends on what you say. If you are saying the compliance to the exposure to the publication of financial report is one thing, okay? Especially the financial analysts, they need to follow a lot of compliance issues. So that is just one example, okay? But in general, the compliance issue is actually set the regulatory, okay, compliance and so on. It looks good, okay? And it also analyzes the compliance of different tools like the NLTK and the sentiment analysis and so on. Although it did not run that code, okay? But it shows the compliance review. Yeah, so actually this chat continues to polish. I do not see any improvements, okay? So it just go on, and eventually we get the summarized report similar to the previous chat. Okay, so I'm going to say this is not what I really want. So there are several issues at this moment. I'm quite certain. First of all, my prompt is not optimal for the agent's workflow to understand it. Second, the design of the chat or the roles of the agents should be further improved. So especially you see, like the critique, how does it identify this information is not actually get from the correct data source. Okay, once I know that you are making something up, can we stop the chat? I think I need to have some safety switch. Okay. And the models are very important because when you change the model, like this one, I think I used the Llama 3.170B, if I remember correctly. But if you change the model, the results are so many. There will be so many variations. One example is that when you change to the tool calling version of the large language model, there will be only code. Okay, no description, no summary. Okay, these are just some of the examples I share with you. So let's go and check the other parts. Now let's go to the app interface. So basically the first one I would like to show you is that I manually input this prompt. Analyze NVIDIA, Microsoft, Adobe. Today is which date? Show past month's performance, market sentiment. Give me an analytical report. You can see in general, we just scroll very quick. You can see this is a very well structured report. But the problem is that the information is not accurate. So in my backend, it was not actually calculated well the information. Yeah, because I already checked some information are very distant from the actual information. So even if it's a good looking report, it is wrong. Okay, and you see there are also some defects here, like financial visualization and chart history. Okay, so I guess a conversation history would be better to save in a PDF or in other formats, and of course nobody will just check all the history except when they try to debug. Okay, financial visualization, I think there is a problem about showing that in StreamIt, because large language model device a code. If you run it in an environment, you get a picture. But how to bring that picture to this page? It is not so easy. If I write a code and run it directly in the page, I think I needed to improve my front end skill. It could be attainable because I see some examples like in the StreamIt and the Gladio website. There are some interesting examples if you want to check. Okay, but so on. What I know is that this workflow. Okay, I have some very good layout of the app and the report, but for the accuracy of the data, how to really enforce the model to get actual data and stop if it cannot do it, I think a more robust flow control could be useful. Okay, now let's take a look at another example. This example is that I prompt the program to see when does Microsoft reach the price higher than $400, comment on the stock performance and make a pleasant joke. Okay, it actually checked the report actually shows that it checked the historical records, but as you see on the left hand side, I write the hard code to get from Y-Finance the data, and you see this March 19, this data is not matching with the report. It's quite interesting because you see the 2024 March 19, for example, you see there is no price matching 414. It's not very different, but it's not 100% matching. Okay, and we see the previous day the open price is 414.25. It's also not matching. So there are still some problem, either hallucination or inaccurate data, right? But as you can see, this report generally looks fine, and behind the scene factors contribute to Microsoft success. It actually, I think some of the information is from a very old news source. Okay, but in general, the layout is okay, and you can see there is also a compliance review report. Okay, and the problem is still the accuracy of the data. Okay, so in order to debug this, you need to check all the chat history and see if some of the definition of the roles of the agent workflow is okay. So let's see. This is another example. Pick 10 tech stock and analyze. It actually picks some of the stock and also shows some of the information here. Okay, like the revenue and so on. This one, I think FB should be Meta, but it missed. It cannot figure out. Facebook now changed the name. I have not yet cross-checked all the data, but from a direct view, if you are familiarized with financial reports, there's no such rounding. No such rounding for all the numbers. So largely, I would assume that most of the data should be rechecked and they are not accurate. Okay, but in general, the layout is okay, and you can see there is also some citations mentioned. And here is another example. So basically, I have a definition of this app. Okay, as you can see in different example, I focus on financial analysis and stock analysis. But this one, I deviate from the predefined task. I ask it to generate some AI news. Yes, it can get some news. Okay, in August. Okay, and you can see there are different news and so on, but the sources is not very convincing. You see, there's no URL, right? And there is another example. I just ask it to analyze the Microsoft stock price. And you can see it actually goes back to January. Okay, let's see January 24th. Let's see if the data is reliable. Okay, 24. Yeah. July 24th, we don't have data. Let's see 25 like this. Yeah, sorry, January 20. We see the price. Okay, you see, it's completely wrong. Okay, I guess I would like to say if if my setting is wrong, I change my setting. If I actually build this Y-Finance tool as a tool and to call it directly is a tool calling process, which I think would be much easier because at least we have the right starting point of all the correct data. Okay, but you see it actually analyze some of the metrics like alpha beta to analyze the different metrics. I think it looks okay in general. But if the data is wrong, everything is wrong. Let's see the last one. Okay, this one actually ask it to generate the AI news in Italy and show some resources. Okay, like where you to get the information, the citation. Let's see this one. If it is okay. Okay, so you see it's empty. UniCredit is empty. Microsoft. Okay, there is no such page. So still, today I showed you that. For the nested chat, of course, you can get better results. As the official example said, if you want to write something, polish something, you have a critique, it will actually improve the whole process. But the critique, I mean, we can have a round table, ask it to join the chat, give some critique, give some comments, right? But if we have a nested structure, actually the whole workflow will look better, and you can focus sometimes to debug only a part of the nested chat. Okay, for example, one nested chat is about critique, we can focus on that. I think this is the main advantage. But to actually bring it to production, like I already did, I have many tests and also many trials. The issue at this moment is that it's quite difficult to ask a large language model to directly involve in the development of the Streamlit app and give a very robust results. Okay, like I said, there are several steps we could improve. First of all, we can hard code some of the tools and to call the tool. Second of all, we can re-examine the whole workflow and check workflow and improve it. The last one is that to incrementally debug or rebuild the tool. So like now as I have the code companion, every time I ask it to build something complicated, it's very difficult for it. Okay, so incrementally, one block at a time, maybe you will get better results. So today I just show you one of the projects that I have worked on. I see some results, not perfect, but could be a very good starting point. I'm going to improve it. In the future, if I have some good news to get some better results, I'm going to share with you. Okay. Wish you happy coding with large language model and to explore more of the current AI trend. Okay. If you have any question, any doubts, feel free to leave a comment. We can explore them together. Thank you. Have a nice time. Bye-bye. Hello everyone, welcome back to my channel again. Today I'm going to show you one of the use case utilizing Claude AI to complete a task. So before I go to the coding part, I'm going to share with you some of the preparation or the tools that I would like to share with you. First of all, I suggest you to have, if you have the OpenAI, ChatGPT, Claude AI assistant. Okay, it is quite useful because it is built, I think, by Claude AI, and you can cite different documentation, ask a question about detail of the design of your program directly here. Okay, it's quite useful. Then is official documentation. Actually, for this part, I use a repo from one of the creator in GitHub. I'm going to introduce to you later. But for the most official part, of course, everything should be already here in the Claude AI. Previously, I find it very difficult to understand the documentation because I always try to quick start with ChatGPT, put every documentation and so on, and create a zero-shot program for me to run. But after this time, I find that maybe my previous attempt to try the Claude AI was not so carefully examined, carefully organized, because there are many details that you need to understand before you go to the coding part. Otherwise, it will not work well. And I also checked some of the YouTubers. They showed you how to use Claude AI, right? Sometimes they use the command line or the other interface, not in the Colab, not in the notebook. So I found it very difficult to start. Okay, but this time I find a very good starting point I'm going to share with you. But whenever you feel confused or you need to modify some of the components, it's better to read the documentation, right? And here is the documentation about the hierarchical process. I think the hierarchical process is what I'm going to use, and also used by the code that I cited. Okay, I actually cited the code created by one of the creator, and he had two versions. One is sequential process, the other is hierarchical. For the hierarchical, it is basically like the corporate structure, right? So I choose this version to as the first trial to test Claude AI. So just a quick summarization. How I quick start. First of all, I find a sample code in GitHub. Then I utilize ChatGPT Claude AI. Then I query the official documentation for any of my doubts and queries. Okay, so now let's take a look at the coding part. So I'm going to start with the first version, is the failed version. Okay, so before I go to the code, I'm going to share with you this part is about the license. So this time I take it very seriously. To first of all, to copy the first original creator, Alex Fazio, his license here, and also mention what I actually changed in my file. And the last part is my own MIT license. Okay, I think it's a good practice to just show who is the original creator. So basically, basically original creator just made the cookbook. You can of course go to his website to check. The cookbook is quite high level and it offers you all the options, right? But now I'm going to focus on Grok option, okay, backend of the large language model of Grok, and I'm going to modify a lot of things. Okay, so I'm going to go back to the coding part. Okay, this part is about. First of all, it's about some warning settings. I think it's not mandatory. Okay, I'm just going to pass it. Installing the dependencies. Okay, so from here, I like the package called Pillow. It was not previously thought or included in the original dependencies, but whenever I run the below code, whenever I think some of the dependencies is necessary, I'm going to add it here. So it is not mandatory for you to run it. Okay, only when you have the debugging process and you see something is missing, you just go back to here and add your packages. This is just my way to do it. Of course, if you want a more clean version, you should integrate all the dependencies in just one code block. Then I get the API key. Okay, so the API key is previously already stored in Colab secret, so I can cite it directly, of course, and also the different information, the different packages that I need to use. Okay. Then here I get the Grok API key, okay, and also, yeah, this is just a ChatGPT suggestion to make some, it's called error handling strategy. So later, I'm going to go to the most important part. First part is about defining the agents. This version, actually, I define the agents very simply, okay. You can see like the stock data fetcher just retrieves the latest stock data from APIs like blah blah blah. This was created partially by ChatGPT, and also here is a very short backstory setting, and also the goal. You have also other information that you want to set, for example, which model to use, maximum iteration, and so on. And the verbose if you want to see the chat records, right? So for every detailed explanation, you can check the official documentation. It's quite clear. So basically, I have a stock data fetcher, stock analysis, and an analyst, a stock news fetcher, and a stock report publisher. Okay, it seems good. Okay, but later you are going to see it's not working so well. Temperature and the models for each agent you can set it differently. Okay, so let's go to see the next part. Is about defining the task. Okay, the task. Okay, so at this moment I just think I give each agent an independent task, okay, because their expertise is quite confined in that specific area. Okay, so task 1 is for agent 1, task 2 is for agent 2. I think this is a standard way because each agent has definition, but you need to assign a task to it for it to work. Okay, so this kind of setting, of course, you can interact with other large language model to define it, because a quick start, some inspirations could be very useful. The only important thing for you to notice is that the structure of the task. Okay, so which kind of information do you want to put inside? Does it work? You need to test to understand it. So later we're going to show you some of the chat record for you to understand. And you see there is also a context part. A context you can see, okay, it has a context of task 1 and task 2. So basically you actually give this task okay, a context. Okay, so just the previous chatting records, and to let it understand the job better. Okay, let the agents understand the job better. So like the task 4, you have the context of task 1, task 2, task 3. Okay, so next part we're going to see the main part of the kickoff of the program. So basically, okay, we just input one of the ticker, okay, for it to analyze. So this part is to kickstart the Crew AI chat. It's quite similar to AutoGen, I would like to say, because you know the agents, you know the task. Okay, you have the verbose setting and you have the different process. For this part, you see, I only see hierarchical and also sequential settings. I'm not sure if there are any other types. And also, I have not yet tested, for example, like in AutoGen, you have the round robin and also casual, different organization of the chat, right? How each agent interact with the others. In here, one part I see how the agents could interact with others. First of all, is by the hierarchical structure. Okay, so one agent as manager. The manager will kick off the conversation table, and you can see for each individual agent you have there is a delegation. Okay, allowed delegation true. Okay, so according to ChatGPT, okay, the Crew AI assistant, it said actually if you set true, it can better interact with others. Let's see if it's true. Okay, so the conversation is very long. I do not repeat to you for every detailed part, okay? But you can see from the first view, here are many errors, okay? I just asked ChatGPT to summarize it for me. So you can see the summarization, okay? So the workflow starts from inputting the ticker, okay? Then there is a delegation of the task to stock data fetcher, okay? But there are many errors. So one of the most common error is that it cannot find the agent. So there must be something about the naming of the agent. So I'm going to debug in the next version. So you can see multiple failed attempts to ask the analyst, of course. Final plan, okay. Despite to use hypothetical analyst plan. Okay, it's good. Okay, so actually agents know some of the ways to analyze a stock. As you can see, let's see if we defined here. Okay, yeah, we defined here. Okay, it's not that did not make it up. So it actually follows the instruction that we gave before, but there is no meaningful results. I tell you, in the end, there's nothing. Okay. So also a stock report summary, we can see that yeah, due to tool malfunction. Okay, so what I noticed are two parts here for the first version. First part is that I needed to better define the agents. So when you call somebody will respond. Okay. The second part is that if the tool calling has malfunction, it means that there must be better with some tool settings. So these are the parts that I'm going to do later. So eventually, let's see the final results. The results, of course, it said required to inform you unable to complete the task. Okay, perfect. This is version 0. Now we are here on version 1. Okay, I'm just going to skip all the parts before. Okay, the settings, initial settings, dependencies, and so on. Yeah, so in this version, I actually tried the detailed tool setting, okay, with the help of ChatGPT, of course. As you can see, I have the tool like a stock data tool, which can fetch different things. Okay, at the first time, I asked it to get the price data. Then I want the financial metrics. I want the other key data. Okay, like I think I remember correctly, the PE ratio and so on. So actually, this class of the basic tool grows larger and larger. Okay, as you can see, the major financial indexes data, it actually linked to balance sheet, cash flow, and stock splits, dividends, very detailed, right? So it's a big class, okay, with a big function inside to define. Okay, what kind of tool I need? I need a data fetching tool. The data fetching tool will fetch all these data. And we also have the analyst tool, right? And DuckDuckGo, I use it as a web search tool. So analyst tool is quite simple, right? Mainly focus on the moving average calculation. Okay, because from a technical trading point of view, it is quite important to understand moving average. For the DuckDuckGo part, I just wanted to check the news and to give me feedback. Okay, if the news is good or not. And we have also the publisher tool. It actually gives a very structured way, right? So you have the data, analytical results, and also the news part, and instantiate the tools to make sure they will work later. Then let's see the agent setting. The agent setting is not very different from the previous version, except like the role part. For the role part, now I do not say, your role is to blah, blah, blah. But after my test, I think the role is better to be seen as the agent name. So just to avoid any misunderstanding, I just put the name and the roles both as the name of the agent. One suggestion is that uppercase, lowercase, make sure they are the same. Okay, as you can see here, I have the first one totally lowercase, and the second one has initial as uppercase. Pay attention to this. Okay, sometimes when they talk with each other, they cannot find the correct one because it's case sensitive. It's quite interesting. Okay, you can try it on the side. I'm not sure if it is an issue of the model, the understanding capability of the model, or the Claude AI infrastructure. Okay, you can try. Okay, as I said, all these agents, I also have the task. Okay, the task is not quite different from the previous one. Yeah, so another difference I want to mention is that now I add the coding agent. Okay, I want the coding agent to actually perform the coding part. Okay, so the main difference, let me summarize again. So basically, now I have the name and the roles both focus on the agent's name. Okay, both of them are agent's name. Then about the fifth agent, the reason I want a Python data coding agent is that sometimes without control, the agents can hallucinate and provide me with the data from 2023. I want 2024. Okay, so I want the coding part to be more precise. And I have these toolbox. Okay, this toolbox is not mandatory. Okay, so as you can see here, in the current version, you see I already deleted. There is a tool option. Okay, it is very easy. You just add the tool option in the agent. Then agent will call that tool directly. The reason in this version I actually deleted it, I created this coding agent, is that if you want the crews to call the tools directly, sometimes it will go into a loop. It's like whenever the tool cannot give you the result, it will query the tool several times. So eventually I say, okay, so maybe my toolbox is not set very well, right? So let's try a free coding version. Okay, I just have an agent to code freely. Maybe it will work. That was my original idea. The other thing is that during the conversation of the different agents, you are going to see if you change some of the information, like if you make the task more complicated or the agent description more complicated, the total runtime will change drastically. For this version, I'm going to show you, okay, in later parts. So the task part is as this one, okay. So as you can see, there is an additional task about the coding part. Okay, so in the main block, actually here I have additional part to set the agent iteration limit. Okay, and RPM limit. RPM is like also the iteration limit. Okay, you are going to see. If you want to know the details, you can check the documentation. And okay, let's start. So basically, you can see this is chat records. Okay, there are many information to get, but unfortunately, I also get the 2023 data, which is not what I wanted. Okay, but in general, it did a lot of query and a lot of calculations. Let's see. In general, this workflow, Okay, first of all, fetch the stock data. Okay, success. Analyze data, no problem. Key calculation is about moving average and RSI. Okay, final insights. Okay, I asked ChatGPT to summarize a very long chat record. Okay, price below both moving average indicate weakening, short-term bullish trend. Okay, and the RSI suggests a potential buying opportunity. Market cap 2.42 trillion. Okay, it seems that the information is correct. Okay, no, sorry, I mean you have some of the information analyzed by the crew. But if you go inside, as I said, whenever you see the volume or the data, okay, it actually shows the data that you don't want. Okay, you don't want to know the data 1 year ago. You can see the trend, but for the latest information, I want to know this month or 2 months ago. So the problem is that maybe I did not specify well here. So I'm going to improve in the next version. Okay, so in this version, actually, after refining the agent's name, it works well. Okay. Eventually, I abandoned the way to fix the tool. Ask the crew to freely coding the code. It seems to work well. Of course, if you assign each tool to each agent, you can try a different version of the code. Okay, so the agents will call the tool directly. Okay, and give you the results. Let's see the runtime. The runtime is around 5 minutes. Not bad. Okay. Another important difference between Crew AI and AutoGen, I think AutoGen for the similar task, it actually performs faster with the interaction with Grok API. But if the model is not so good in AutoGen, you will not get a result. But in Crew AI, it seems that the full flow control is better. Okay, it actually gets whatever the hallucination is, or if the model is good or not good. As you see, I also used Mistral and other models. It's not so bad. Okay, at this point. Eventually, you have the summarized report. Okay, for this simplified version. It actually said the date is 2023, February 3rd. Not useful, but this result is not so bad. Okay, so let's see the improved version. Improved version, okay, I'm not going to show you everything. Okay, so let's go directly to the coding part. To the parts of the change that I made. Okay, so let's see. For the agent setting, you see tool calling, I'm not changing it, I'm not using it. Okay. For the agent setting, you see now I have a backstory which is longer. I asked GPT to make it more robust. Okay. So you give more backstories like job description. Okay, and of course you have the goal like the previous version, of course. Then let's see the task. For the task is much more detailed. So we have the description of the task. We have for example, like this one. Your task is to get the price data for the ticker for the past range period. Okay, from which date? Okay, so I want to be precise. The reason for this is that if I do not precisely tell the agents to look backward, sometimes it could look forward. Example is that if I say, okay, now today is which day? I want to see the performance of the stock, okay, over the past several months. Okay, if I don't say past several months, it might look forward. So the more precise you have in the description, the more contained your response will be. So this is just one of the suggestion, is to make sure the task is specific. The more specific it is, we might get better results. We're going to see later. Okay, so I ask open price, closing price, highest price, and so on. Okay, very detailed. Okay, but one of the problem you are going to see later, I have not yet resolved, is that, for example, here, I really would like the agent 1, okay, when it solves task 1, it will delegate the task directly to the coding agent. However, if you see the actual conversation, if it starts to hallucinate or take some of the information already embedded, I say embedded in the large language model, it will give you some historical data it was trained on. Okay, the model was trained on, and will not call the tool. And eventually, when the crew manager actually calls for the coding agent, it will go to a very interesting loop. So let's continue to finish this part. Okay, task 1, task 2, task 3. You see, it's very detailed. Okay, so for the setting, for example, if you have this task, you can, of course, if you're already working in this field, just add the information that you think is very necessary. If you are not working in the field, just check some of the reliable sources to see how the task is constructed. Okay, so you will get better results. So let's see. Okay, so here, like the coding agent has also a more robust description here. I do the calculation and see the data anomaly. Okay, it's very burdensome. Okay, it's not an easy task. So dependency, like I said before, if I meet some problem running the code, I will come back to install some of the dependencies. Okay, so in the main part, there is a calculation of the start date. Okay, it looks good. Actually, it will better confine my prompt. Okay, to let the team knows that what I want. And you can see after choosing different variables and to take the user input. For here, I just don't. The first time I run this code, it took me 1.5 hours. And I did not see a result, so I set the limit for the maximum iteration and RPM to 2. And here we can see I put all the inputs, okay, the different inputs here, and the prompt, okay, inputs are going to be fed into the team, and you are going to see, okay, now we're starting the analysis of the stock, blah blah blah. Okay, so here we can actually define, okay, what the user actually input. Okay, these variables are going to be used. Okay, so let's first see here. So please enter the ticker. Okay, additional words, I want a comprehensive report. Okay, enter the date. Today is the date, and the information range of my month. Okay, so it starts working. Okay, it will start working, and as immediately you see here, it actually go back to 2022. This is not what I want. But eventually, it goes on talking a lot of things. You see, there is a very interesting loop. You see, whenever it gets some of the information, it will evaluate, not okay, will go back, and so on. So just to save your time, let's go to the summarization. The response is about 5,000 lines. So I summarize it into 3 parts. Okay, I take them to 3 parts to summarize, because ChatGPT cannot intake such amount of text. So let's see the first part: user input, data verification. Okay, verify the accuracy of the data and so on. Yeah, it's good. Retrieval and formatting. Okay, it works. Okay, especially with the Python data analyst. Let's of the stock movement. Okay, so yeah, looks alright. Okay, looks better than the previous 2 versions. Okay, let's just not think about the runtime for a moment. Okay, so in general, the quality has improved, but also the complexity you can see also increased. Okay, so the other part is about okay, so actually in the second part, the agent starts to realize, okay, now we're talking about 2024, September 8th. Okay, so, and also there are some key events identified in the news, and I think at this moment, when it talks to the agents, not the first agent, okay, not the data fetcher, but the data analyst and so on, there are some additional tasks assigned to different agents. This is not a coding agent. Let's see our coding agent. Okay, our coding agent. Yeah, sorry. Our coding agent is Python data analyst. Okay, name is okay. Yeah, so go back and specify the package to use Y Finance to get the data. Okay, looks good. Historical average data. Okay, perfect. Summarize the report. So just during the process, you see there are some repetition. It's not that we finish one task and move on. It will go back, okay, one way or another. So the third part, we're going to see there is a goal, the stock data, news summary, and so on. But you see here, the agents are going to utilize the API for Alpha Vantage. We don't have that, okay. So this is something that we would like to avoid in the future test, because if it goes out of the range, it may cause problem. Because some of the APIs, you cannot just ask agents to imagine, okay, create one API for you. You need to create it by yourself. And for me personally, at the test stage, I prefer everything free, like Y Finance package and so on. Yeah. So basically, the news summary and the stock matrix, everything looks fine. Okay. Yeah. So let's see the final result. Okay. The final result looks not so bad. First of all, it shows stock price data. Well, we can see that this is stock price and stock analysis. Okay. Looks quite good. And also there are some notable movements following for the following news. Okay, looks fine. News summary from August to September. Yeah, you can see this is a sentiment analysis. Okay, in the future, if I get a chance, we are going to explore the sentiment analysis together. Okay, at this part, okay, it does the crew team does the job to analyze all the sentiment. Let's see if it is correct. Let's see this one. Lawsuits, okay, negative, yes. Apple Card Plus, positive. Okay, if you are interested, you can check validate all the news here. Of course, if you ask Crew AI to add the source of the data, I think it's possible. Okay, just need to carefully design. About our coding agent, okay, Python analyst, because he also provides some of the outputs. So in the final summary, it actually summarizes all the information from different agents. It's like one agent for one part. Okay, it's orchestrated well. So in the future instance, I would like to avoid showing the code in the final report, right? So I would like to say, I just want to see the main part, and eventually give me a buy or sell recommendation, and look forward for some future periods. I also checked if Crew AI can generate a graph. It is a very difficult task, as I find in AutoGen. In their official documentation, I can see that the agent creates a PNG file, picture file of the stock or something statistic. But here in Crew AI, okay, at the first check, it could do the similar things. Can they show it also in the final output report? I'm not sure. So in the future, we are going to explore them together. So just a quick summary of this journey. So Crew AI is a good tool. I would recommend you to check the official documentation and also check in GitHub like the cookbook that I checked for Crew AI. You can get some inspiration to build your own app. And for each of the detail setting, you need to try, okay? Like I said before, some of the parameter you can let loose, okay? Give some flexibility, but you will have longer conversation. Or you just give it a very specific tool, like to the agent. But be careful, if during the conversation, it cannot meet the demand of the agent, it could create a problem. Not necessarily saving time, okay? So there are some balance you can try out, okay? Just do more tests. My suggestion is eventually, as you can see, I have 3 steps, okay? I have the simplest version. I see some results, okay? The workflow is working. Then I improve and improve again. Eventually, as you can see, the last version of course looks very well, okay, compared to the previous versions. But the key problem here is that the runtime. Let me see if I already marked it here. Yeah, the runtime is around 1 hour. So you need to see if this can meet your demands. Can you wait 1 hour for the report? Okay, and if you have a budget for the API, for example, we are using Grok freely now, but if you are using ChatGPT, you use OpenAI API. What is your cost budget? You cannot always let it go freestyle, right? It generates a lot of nonsense information, and you pay the cost for the tokens. Okay, so yeah, that's all I wanted to say. Utilize the tools to quick start agent flow. During the iteration from simple to complicated version, do it step by step. Do some test, and some thresholds, some parameters always change, and to see the results. For the description of the agent, description of the tools, organization of the chat, always check the final results and see how you can better design the app. Okay. If you have any question, any doubt, feel free to let me know. We can explore future possibilities with AI, with agentic workflow together. Thank you. Have a nice day. Bye-bye. Hello everyone, welcome back to my channel again. Now I'm going to share with you how to deploy the Llama 1.5 model through Grok and in local environment utilizing the Open Web UI. If you already saw my previous video, you should already know how to set up the Open Web UI in local environment and open it. After logging, you can see the normal interface of the chat. Of course, if you already tried Llama, for example, for my case, I already had some of the model like the Mistral model to run it directly. Now, in order to add additional models, like from the Grok website, you go to the admin panel, setting, connection. You just input this URL. Okay, it is from the official document of Grok. You can also see this one in the Grok website. Until this URL, api.grok.com/openai/v1. Okay, until this part. Then you should copy paste your API key here. Okay, and then you try this one, verify connection. Once you see the verified sign here, you should save. Okay, and it will say save successfully. So after this setting, you refresh the interface. Now you go to the new chat. You should see all the models available in Grok. Okay, so basically, if you already have some models through Llama, like what I had, you should see those models are still here. Then you see additional models of the Grok hosted model. Okay, so basically you can see here, if you see this link external, which means it's an external model. Okay, so let's see some example of utilizing the Llama v1 1.5. Okay, so originally I thought this model should give bi-directional capability, which means that it can generate a picture and decipher the picture. However, it's not the case. For example, I ask the question to draw the AAPL price trend. It gets some of the data it was trained on, but there was no picture generated. Then I asked it to draw something. Okay, I wanted to say draw start, so it actually gave me this one. But if you ask it to draw something else, for example, you want a picture, it cannot do that. So the next one is explain the picture. This is a Google Map screenshot I did before. It explains the general structure of this picture. Okay, so it's a street map. There are some elements inside. Okay, and it also explained some of the details, like the track where some of the roads occupy a large portion and so on. So it's a general description. Okay, and this is another Google Map screenshot. As you can see, the description is almost the same. Okay, it gives some high-level generalization of the information inside. Now we try another picture. This is a picture of the let's see, the total health benefit cost of the employee, workers' earning, overall inflation. Okay, the relationship of this chart. And you see, it only says that this shows some of the information like average annual salary, cost associated with it, and so on. But it cannot get more info. Another issue about utilizing this model in the open web UI is that whenever you try to follow up a question, for example, I say here, I say more detail. Okay. Usually you will get this error, bad request. So basically, whenever you want to query a picture, you need to start a new chat. Okay. I'm not sure if this is my local setting problem or not. You can try it out. Let's see another one. So this is International Monetary Fund, some of the statistics about the growth projection of the different economy. And you see, it actually gets the information, okay, growth projection, which year, okay, and it says, okay, there is a wide range of outlook projections, and says what is used for, okay. It helps the viewer to better understand. So still general summarization. Then I ask you to explain this picture from Fight Club, a very famous movie. However, it got stuck. Or if you try again, it will say that this picture is oversized. So there is also a limitation about the size of the picture. So I suppose there is is like the context window for language model, right? So multimodality model, it has also some of the limitations. This one is actually about the loss function. I just randomly picked some of the pictures on the internet, and this is a general depiction of the loss function of the neural network. It actually says something else. It says flowchart explain how data is processed in real time, but there is no such information there, okay? However, if I think this model actually pick up some of the traits, like there is an arrow, so arrow means trend, arrow may be in motion, so it actually connects this idea with real time. Okay, so it says this is a real-time processing of the data, but however, the essence of this picture is a neural network. Okay, so this it deviates a little bit from the reality. Let's see another one. Now, this one is actually a hypothetical organizational chart, which you can see the hierarchical structure of the organization. Yeah, the model can identify this is a business hierarchy. Okay, shows names and emails. Okay, seems okay. And also it shows the names, which means it has some capability to extract information. But that's it. It just gives some example, but not all, right? Not like a complete list. So I did another experiment. I asked it to actually generate all the text, okay, to extract all the text information. So it has still replied to me the traits of this picture, but it's not like OCR. It cannot just get all the text information and give response to me. So I would like to say that this model is has a limited capability, but if you want to experiment with it, okay, you utilizing this open web UI, or you write your your code in Python, you can always try it. Okay, I wish this tutorial is useful for you. If you like the video of this kind, or if you have any question, feel free to leave a comment. If you like my videos, please subscribe. Thank you very much. Bye bye. Today I'm going to analyze the presidential debate between Harris and Trump, and I have got the ABC partial transcript of the presidential debate, and I also gathered the data from a secondary source just for local analysis. And for the ABC partial transcript, I mainly use GPT-4o model. So let's see what the result I get. So basically, if I keep asking ChatGPT 4o model about the presidential debate claims made by each candidate, and it will give me this statistic. It actually categorizes the claims to be accurate, misleading claim, and also exaggerated. So after running the analysis of the transcript, it actually keeps on going beyond the scope of the transcript. So eventually it made around 124 claims extracted from the speech of each candidate. And you can see on the left-hand side, Trump has more claims than Harris. And you can see largely of the Trump claims are exaggerated, and false is 25.8%, and the accurate claims only 12%. And there are also 24% of the misleading claims. However, on Harris' side, the accurate percentage is much higher, although in general the total claims is inferior, less than Trump's side. Okay, so on the right hand side, I actually subjectively imposed a 20% error margin, okay, to see, okay, if the model makes some 20% mistake, how would they range? So basically, with partially checking the actual transcript and partially hallucination, you can see that this model can give us this statistic. Okay, then I try to meet the hallucination. So first of all, I ask another Copilot to actually ask how many paragraphs in the transcript in ACA website, and then tell the G model, okay, there are these many paragraphs. Okay, can you analyze paragraph one by one? So in this way, actually, I give it a limit. However, there may still some hallucination. It actually has a error margin is around 2 paragraphs. Okay, not many. Okay, but it's still we have the avoid hallucination still. So we need to guide this model every step forward. However, in this version, we can see the Trump claims are still higher, okay, in percentage higher than Harris claims. And the inaccurate claims made by Trump is still large, okay, 37% of the total claims on both sides. And you can see 27.2% of the accurate claims in the total claims. And the Harris side has accurate claims higher than the Trump side. Okay, and on the right hand side, you can also see the bar chart of the claim counts and also 20% error margin. Okay, so basically, we cannot give a conclusion about whether the analysis is accurate or not. First of all, if it is accurate or not accurate, we need to verify from different sources. And I read one of the posts by one of the professors in university. He actually said now some of the sources, like the websites or internet content, keeps disappearing. So whenever we do a fact check, now the difficulty has increased. Okay, so basically, if you are going backwards to check some of the facts which are recorded by internet, the difficulty will increase as the time progress forward. The other thing is about the model. Okay, so the first point is that we assume that the model can get all the internet content. Okay, but the internet content could disappear, so it is very difficult for the model to verify the claim, also difficult for us. The second point is about the training set of the model. If the training set of the model was largely favorable to like Harris' side, so the eventual results will pivot to her side. Okay, but I do not know how many training data are used to train the political side of arguments, so we don't know. Okay, the last one is that natural language processing and large language model analysis are totally different things. Just like you see in the next page. Okay, so if I try to do the local analysis on the transcript, but it is very computational heavy. Okay, I needed to use multiple models. So the fastest one to count the word and also to give a word cloud, this is the most direct thing I can do. But if I really want to do the natural language processing, it will involve much more efforts. Although I've not done it yet, if you're interested to do also your own analysis, but it is also easy. So this is a partial this side. I wish you could give you some information, and if you want to dig deeper in the processing, please try different. Now I'll go to the ChatGPT and see how it goes. So as you can see, the first I tried to analyze the transcript. I actually set a PDF format and start to analyze, right? So at first the model actually just displayed okay, first of all, he asked me to identify which is the first paragraph I want to start with. I just write. So actually goes on to the fact, but it did not do the functional, like to cross-check the internet content and so on. So basically, the whole chat is based on the training dataset of the GPT. So it keeps on going to check each playing, but it does do a good job to separate one paragraph or one piece of speech to multiple claims, so you can view it clearly. And at some point, I asked the model to actually start counting the claim types. So from this point forward, the statistic will start building. And as you can see, at first, some of the paragraphs are well analyzed and all based on the true transcript until I think around here, right? Until here, actually the model starts to hallucinate. This is not the actual text because I just search the partial wording. It's not present in the transcript. So the model starts to hallucinate. Okay. So let's keep on going. And eventually we get the statistics, and we can ask GPT to analyze, okay, display the data analytical results, okay, as I just showed you before. Okay, this is version number 1. You can see that the model hallucinated a lot, and we get this results. Then let's see another version. In this version, I actually guided the model to make sure that the response is more accurate, or at least statistically more robust, I would say. So this time I also simplified the count to accurate and inaccurate. Okay. Because I want to say, I don't want to analyze the emotion, like exaggerate or not. I want to say, okay, is this fact or not fact? Okay, it starts to analyze, and this time I only ask it to show the first sentence, so I can quick check if this paragraph exists or not. And it does the job. Okay, just to save time, I ask it to do 10 paragraphs for each time. And eventually, I think about here, the paragraph, if I remember correctly, is around 48 or 46. It actually goes beyond that. So if in the prompt actually guide the model to make more accurate results, you still need to guide until the end. And with a small margin of hallucination, we get the results. Okay, so this is just a quick analysis of the Trump-Harris test. I wish it is useful, and wish this could also be a good start for you or for me to analyze similar language contents in the future. If you have any question, if you want to discuss anything, feel free to let me know, and have a nice day. Bye-bye. Hello everyone, welcome back to my channel again. Today I'm going to show you a quick project about the sentiment analysis of iPhone news. So basically this project will involve one of the algorithm and also the repo of TextBlob in GitHub. This is a tool that ChatGPT actually recommended for the sentiment analysis, and we are going to go through the code step by step. Basically, I went through 4 iterations of the code, as you can see on the right hand side. Okay, so basically we first got this version of the code. So we have the function to get the iPhone news, then another function to analyze sentiment. The important thing is to actually categorize the sentiment score, so you can know it's positive, negative, or neutral. And so this is a function to perform the sentiment analysis and news results. Okay, so this one is focusing on utilizing TextBlob. This one is to conduct the result analysis. And we also need to plot the results because I want to see it visually to get a better understanding of the sentiment analysis results. And And let's see, the first result actually was like this. Okay, so basically I have everything is neutral. So the intuition tells me that it is most likely the problem of the data set. So basically I get the news from the let's see here, from this function I utilize the search query here. Okay, and I use the package Google search. Okay, so basically the search results, if it only returns the title or the URL, the analysis will not give any meaningful results. So the next iteration is to describe this issue. Okay, I did not even go to the details of reviewing this code, but at this step, I think the first thing is to actually see some distribution, okay, of the sentiments. That will be more useful. So I keep on iterate the code and see the second version. Okay, in the second version, actually there are some improvements. So basically the function changed from the get news to get full article. So for each URL to get to pass the HTML and to get through the beautiful soup to get the information, okay, and to separate paragraphs. Yeah, so the text from paragraphs. This way, we are sure that we are going to analyze the main contents. But remember, my code is only the first step. So in a more rigorous way, we should actually handle the text message more carefully. Especially, we need to do a lot of pre-processing, like what I did some time ago when I analyzed the job description. I needed to eliminate all the punctuations or the different characters, special characters, and so on. But here I did not. Okay, I just do the easy way to build this framework, and the others mostly to change. So let's see the results. Okay, this distribution is more sensible. I would say. See here, there are mostly positive news, then small amount of negative news, and also some new news. Okay. So the news about a specific product could be used to understand the news views of the specific product. Because sometimes it's quite difficult to do a market survey. Although different ways to do this to collect the statistical data could be biased in some way. But I would suggest to use more ways to analyze about a specific product. So we can see that each product, the segment analysis result is shown as well. Okay, also we can see how many positive, how many negative, how many neutral. But still, for this kind of graphical presentation, I cannot understand the involvement. So it's better that in a later stage, I'm going to see a pie chart or the other charts. Okay, so in the fourth version, I'm going to present also the pie chart. Okay. And here I also notice a problem because each product, after the search, I get a different news count. So basically, I think the package search results can vary based on the topic I search. So this could potentially bring some bias. Okay, so basically, the source of my sample data is not ethical quantity. Also, I needed to further investigate how the news were searched, okay, if I would be more rigorous. But as the initial results, I think this can give me some indication, okay, about the sentiment on the news side to this product. Okay, so yeah, also each version was posted the GPT comments about the version of the code. You can see there are many ways to improve. So I just leave it here. Do not go to more details. Okay, let's just go to version 3. Okay, version 3 actually asks GPT to double check about why the articles are different. So there is not a direct answer, but I arrange as a graphical representation about sentiment, so I can have a approximation of the future. Okay, but as you can see here, I can only say, like iPhone 14, we have steady positive news, which is higher than the iPhone 15. But since the sample size of each research are not the same, we cannot compare in this way. Okay, so here we have the fourth version. Okay, the fourth version. Let's see the code. Yeah, so basically, in this version, I also added some of the requirements. So basically, I want to see the original website. Okay, so basically, I want to double check. I can see the URL. Okay. This is okay. I get the URL. The information is is able to be double checked. And I also want to categorize the channel. For example, if the news channel is from like CNN, like other news source and so on, or it is from the other source, okay? But eventually most of those are other sources. As you can see, we have one New York Times, which is specified the channel as mainstream New York Times, but for the others, most of them are others, okay? So it does not make much sense to actually visualize because most of them are other source. So I guess the result is quite scattered in the internet. The randomness seems okay. All right. Yeah, and for each news, we can still see the polarity score. Okay. And let's see. Here, this function will make sure that we have the 3-column results of the graph in the end for us to visualize. And here we can see the classification function of the different channel of the news. Okay, so these are the two, and also here. Okay, known channels. Okay, I gave some of the examples. So this function actually helped me to understand which channel it is. Okay, so both of these functions, get a channel and then classify, work very well. But I did not put the visualization part on this statistic classification results. Okay, basically see the result looks okay, and I expanded iPhone X, iPhone 10 to iPhone 4. Now let's take a look at the final version. Okay, the final version is still running because I think the job is very intensive. Okay? But in general, it does not change in the general structure. But usually we have a different way to deal with the data. Okay, so we can see here that we have the percentage of the positive, negative, and true news. So since each size may have small deviation, we cannot give conclusion that okay, the trend is more negative or more positive, but it does still give you some approximation. Okay, let's see here, like iPhone 15, we can see the negative news actually has a very small percentage. We can see that there is an improvement from 14. Also, you can see the neutral part, but the neutral part has increased a lot, around 7%. So in general, the positive comments and positive news has decreased about 6%. And let's take a look at the iPhone 13. We have 90% of the positive news. So is the market taking the new iPhone release a little bit tired? Okay, they are tired of the small improvements and the high price. It could be a possible explanation. But here I just showed you a quick view of analyzing the sentiments of news on a specific product. You can actually implement this to different products, but remember, always pay attention to how you gather the data, how you pre-clean, how you pre-process the data, and how you cross-reference, okay, cross-check the validity of the data, and eventually how you display this data. Okay, about the natural language processing, I mean, the current methodology I used is just the start. Of course, we can use different natural language processing models. In the future, I wish when I dig deeper to that, I'm going to share with you what I find. Okay, so feel free to use this code. If you have any question, leave a comment. If you like my channel, please subscribe, and see you next time. Bye bye. Hello everyone, welcome back to my channel. Now I'm going to share with you another small project. It's called weather forecasting. So I should not have started this project because actually when I saw the Wikipedia page about the weather forecasting, it is a very complicated subject and was how these models perform. Again, if you want to dive deeper to the theory background, I really recommend you to look at the Wikipedia, like official books, okay, to get more robust descriptions. Below, let's go to see the code. Okay, so basically I have the first version of ARIMA model. So okay, I use the package. The most important package is Meteostat. Okay, this package actually can get the weather information, okay, basic weather information for me to do the analysis. Okay, I'm going to focus on several variables you are going to see later. So basically, first of all, I need to get the weather, so I have this function. I choose New York as the analysis start. I just choose this location, and I have a time period from 2020, okay, and also I get the data and also print the data head. So basically, I'm going to have the temperature average, blah, 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 1, 2, 3, 4, 4 variables, okay, as you can see here. Then I pre-process the data. So it's there is one of the experience that I will share with you for any numerical data. It is better to standardize. Actually, to make sure they are on the same range, it will be better for you to analyze. So if, for example, if you have one variable is 1 to 1,000, another variable is 1 to 2, the range actually will impact the analytical result very significantly. So this min max scalar, okay, this kind of transformation is useful. Okay, you have many other transformation methods you can try. Then I use 60% of the data as training, 20% testing, and also print the shape of the training and test data. And now we are in the modeling part. Okay, so basically the most important part is first of all we need to understand how to evaluate the model. Okay, previously you already understand how the model works, but how good is the model, I think, is the most important part. So I need to I just chose the metrics to evaluate the model. Of course, you can add other metrics in it. Then we do the forecasting utilizing this model. Okay, so basically further the feature, or I say the parameters of the ARIMA of B, D, Q, 3 parameters are preset. Okay, just for simplicity. Then we do the prediction and transfer prediction to a real scale. I think this part is out of my expectations. So ChatGPT really did a job to mention this part because we need to see the original forms. It's better for us to understand. And then you see this model result. Okay, yeah. So after this code, I think visual. Okay, I cannot do variations. And here I try to fine-tune this model. Okay, so basically for the different variation of the model, I will see the results and add this widget so I can choose a different parameter and train the model. It is strongly suggested because recent days I find the Colab widget documentation is super useful. It will make your interface very intuitive. You try the different parameters, not here. In the future, I'm going to tell you how to use it in the artificial neural network. Okay, when you try this, each time you are like doing experiment, it will give you patterns. Okay, so like in this case, I change one parameter, it will give me one result, right? So in neural network, when I change layers of the neural network into neurons, I see the results, and I can even say I can see how much training time do I need, okay, computational cost, and see of the algorithm. I can find the balance. Okay, for small to medium data set, I think you have to do this kind of test to choose. If you want to scale up, it is another story. You may need to use different tools to handle data sets. But in the first experimental part, I think some of the widgets will be very useful for you to test and see the results. Okay, so first version, okay, I understand there is a model, right? And a model actually does the job and also provide preliminary information. So let's try to improve. Okay, so this part, collection processing, I just leave it here. Okay, then I still utilize the widgets and try to predict. Okay, in this version, okay, I can see different variations, right? Each time when I run this model, I change the parameter, give me 1, 1, 2, run 3. And I also, beside, I can see, except I can see this matrix comparison, I can also see the actual predicted value comparison, okay? As you can see, it is not very good for the direct visual examination, because you can see the predicted value and actually are quite deviated from each other. So at this step, we know that widgets and different visualization work together well, right? We can move on. So in the certain ARIMA model, okay, let's see here. version. Of course, we install dependencies, then we go to the main part of the code. For the main part of the code, actually the key difference here is to make this kind of layout and also mark the dates. Whenever you handle the data set, you need to pay close attention to how you use the train and test data and how you make the prediction. Okay, so for example, I choose this period of the data to train the model, but eventually I want to predict for my forecast days is 7 days. Okay, originally. So what my original intention is to use all the historical model to train the model, historical data to train the model and predict the last 7 days of the data set. So you need to be careful to change the parameter to make sure that your code does this job. So sometimes when you split like the train and test data, there is a tricky balance. How do you separate the train and test data, right? I still separate that 20% train and 20% test, because my forecasting range is inside of the training data set. Inside of the dataset, I do training and testing. So it is not 100% robust. You can also have a different setup, like you have a train, validation, and a test. So you can leave the last 7 days data not seen in the dataset and to train model. Okay, that's the approach. Personally speaking, I really doubt the difference. Okay, because the 7 days data is very limited. Okay, but you can try. Then I can also see I can see as a matrix comparison. Of course, the error test as small as possible. So let's see if I change the parameter here, okay, and I see there is an increase of error. Of course, choice is a bad choice. Then I have another one, and I can see my error keeps going up. So there must be something wrong. And also pay attention to some of the errors mentioned in the package. It will not stop your front, but it will actually give an indication to how to improve the model, okay, or algorithm. So you can see the next one here, okay. Alright, so the error actually dropped a lot. I think it is good compared to model 3. Okay, so it just shows you that if you want to experiment and see some change of the graphical representation, I think it's very good for you to understand the different parameter tuning and give you a very direct sense. Okay, not always just look at the pure number or pure description. Okay, so that's good. So now look at the other two models. One is called the VAR model. Okay, for the detailed code, you can check later. Of course, the main part is about training the model forecast with VAR. It's very simple, right? Because the heavy work is already done here inside of the package. Right? So let's see. In the end, we still have the widgets to change the parameter, change the sample data range, okay, and to see different results. Okay, it looks pretty good. Okay, each time you can see the model predicted this data, how does it perform? Okay, then you add another round, another round. Okay, so this is a good way to test the parameter tuning for any model. I really recommend you to add a widget to your Colab notebook or any of the model you want to learn, you try. It is very useful. Okay, so basically the VAR model is different from the array model because it can handle the movements of different variables together. Okay, I give you a simple explanation here, not a feature one, of course. And here, see the long-short memory. Long-short memory actually is more computational intensive because it actually takes more time to train. You can see this one. This one is a long-short memory model. If I remember correctly, this is from the package of TensorFlow. Okay, whenever we say TensorFlow, it means that we're into the deep learning area. Okay, we can simply understand like that. Okay, so we have this big function that actually predicts. Okay, using a long-short memory model. Okay, so for the detail, I think this is similar to other deep learning model. You need to understand input and output shapes and the data, and you set the different parameters inside of the function. And the attention part is about the box. You want to see the training process, either in here or the network. If you set one, you see a lot of training process. You see results. Okay, so the answer is basically see, and as stages, and you can see here the progress. I think it's useful to know you're going to what. Otherwise, through Llama and VAR, see it by very quickly. But largely, they're not intensive, so you are going to move slowly. This one is all customizable. You change it, you are going to have the visual. Okay, so let's see. Similar as the previous one, but never change like the window size and 4 steps. Okay, we can see different results. Okay, so basically the focus steps means that how many days forward you want to look, or in case how many days of the last days you want to use the model to forecast. Okay, so here we have it. So as we can see, okay, although my choice of the training about the training validation test has problem, right? Just for simplicity, I just separate to train and test and use this model to actually predict the last 0 days. Okay, directly. So the eventual result, as you see, modeling or forecast 7 days of the weather stats is not so easy. Okay, as I said, weather forecasting is a very complicated subject, but at least we tried some algorithm. They are not working so good. So let's take a look at another way. As you can see, this is the data set I show here. Also, you can try directly with Colab default function to visualize the distribution of different data. Now let's see from another perspective. So since the widgets are very useful, we can just get the data, okay, weather data, and we just use the widget to display it. The reason I want to also recommend this way of visualizing data is that you see the weather, it has the seasonality issue, okay? It is one of the issues that we handle the time series data, either economic or other data. So every year you see there is a circle, right? For each month, you have a direct trend, like from August to September, you have a drop of temperature. So like a common sense. And if you see the historical data, it will give you indication of how the weather will be like in the dates that you want to check. So this is another way to, for our personal use, for us, if I want to understand the average temperature or the trend, I can just check historical data without predicting, okay? So in the future, I'm going to share with you other test data. I use complicated models, and usually that's okay, this model fits the data. It is close to the historical data. So which means that for some of the models, they can generalize on the information. But if my feature space is not large enough, for example, if I not consider factors impacting the weather, my model is useless, like the previous 3 models, right? So I can either complete machine learning or deep learning models, or I just check the historical data. Okay, this is the first saying that all the models essentially are okay. So as you can see here, in the first instance, if I choose a variable, okay, I can see the several years trend, okay, on specific months, first January, February, and so on. Okay, this is the first version. You can see we can see a trend, but it's not very clear. So let's see how we can improve. So the second way, I choose a variable. I can choose multiple years. First of all, it will show me the daily trend, okay, of a specific year or each month. Okay, so I can understand, for example, in this month, and compared with the other months, how the general trend was. For example, in a specific month, you can see this is December. In December, you have a very drastic temperature change compared to others. Okay, of course, you can also choose other visualizations. This is just preliminary version, and you can also see here the trend of 2024, for example, is similar to the previous one. The only issue is that 2024 we have data until December. This one is the bar chart that we can see the range. Okay, the change of the range of the temperature. For example, this varies temperature each year, like blue line is 2023, orange line is 2024, from which 2 degrees, okay, and in which month situation, this is March, okay. So in that way, you can say, okay, in 2024, we have the average or the general range of the temperature is lower than this year, and we also have a higher average temperature in some days. Okay. But if you see this case, can say, well, this is not the case. You can say maybe things actually shortened, okay? So the highest temperature is lower than the previous year. So it is very hard to first the weather data, but we can get some indication to support our decision making on daily life. Okay, so also have the version 3. Okay, in version 3, I also added this choice of different city. So actually, you to look at the code. Okay, so if you only utilize this variable, string variable, to get the coordinates, you either need to have an API to query a database, or you have a package that you can use to get your coordinates, or you need to ask a large language model. So in this case, I directly ask GPT to provide me with these coordinates, so I can choose from the drop-down menu. So it works fine. So I choose Rome, Italy. I can understand the weather trend and information of Rome, Italy. I choose multiple years from 2022 to 2024. Okay. So this is the information that I can get. Okay. First of all, from this project, I think you know to experiment on the weather data, we choose a free package. That's the first point. Second point, we try different models. We need to understand how it works. Okay, the background of the models, how they handle variables, and furthermore, we always check the different models, okay, the models algorithm, which is a situation most suitable to utilize such model, such algorithm. Because if we have different sets, different problem sets, okay, which problem we want to solve, we need to choose the appropriate model. We need to process. Not only to choose model, also future. If we get deeper machine learning to learn implied model, modality model, we need to understand our objective. Okay? And if we are not just simulating or doing regression or in the training of the model, we would do a step to understand to choose the model to have a large data set, or to fine-tune model with limited resources, or even, if you have a really enough source, you can also develop your language model, train your own model, right? So that is data science. It's about machine learning. It's about large language model training and development. We need to always evaluate the pros and cons, different approach, and choose the best one to reach to our target. That's all for this episode. I wish you like it. If you have any comment, feel free to leave a message to me. And if you like the videos, please subscribe, and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today we are going to do some tests about the two transformer structure models. One is called BERT, the other is GPT-2. On my right hand side, now I'm going to run the code and prepare the interface. So later we are going to try it out. I'm going to run now. On the left hand side, we can quickly browse the model information. In Wikipedia, like GPT-2, you can see that it is developed by OpenAI, and it is second in the foundational series of GPT models. The later ones are GPT-3 and GPT-4, now GPT-4o and GPT-4o1. Okay, we are going to test the GPT-4o1 in the later series. Okay, so in this model, if we really want to dig up and discuss all the details, there are a lot of things. Okay, it actually involves a lot of design of the model and how it is trained and so on. Okay, then there is another model called BERT. BERT model is developed by Google in 2018. It is a very famous transformer model, and for most of the courses in university, now it is a master learn topic. Okay, it is the official name is a bidirectional encoder representation from transformers. Okay, and it is trained on the mask token prediction and next sentence prediction. So basically, either BERT, GPT-2, GPT-3, in my opinion, they have a different design, or progressively they have some improvements on specific task. So whenever you approach a model, it's better that you understand what it is meant to do. Okay, so it is designed for specific task, or generative generation of text, or specifically on some task. For example, now we can also see some large language model hosted in HuggingFace, and we can see actually there are some models you see specific on the coding task, fine-tuned for different purpose, and so on. So whatever model that is, we need to understand what it's designed for and the basic structure. Okay, if you want to review in detail, but if you only want to use it, you have to understand it and its limitations and pros and cons. Okay, so before the code has a pro, I'm going to rerun it. Before that, let's quickly take a look at the model I'm going to introduce. So basically, we have GPT-2, GPT-3, GPT-J, and BERT. Okay, I just put them all here for some comparison. Okay, larger model, the more parameters you are going to see involved inside of this model. And as you can see in my tutorial today, I'm going to show you the GPT-2 and BERT. The reason is that in Colab environment, you can load these models easily and even interact with our user interface and to try out. But for GPT-3, it is not first of all, the Colab free tier does not allow to load the model. Okay, it is very big. Second of all, we do not have a direct source to get this model. But for GPT-J, I already tried, and Colab already crashed several times. But anyway, if you have a larger quota of the computation resource, you can try it. Okay, I also leave it here. So I'm going to rerun it and let's test it. So first of all, let's check the BERT question plus context simple version. So as you can see, this code is quite simple, right? We first of all import the necessary dependencies, and in Colab, I think Torch and Transformer are already installed. The reason you saw the previous error is because I did not install Gladio. Okay, Gladio is not a default package in Colab environment. Anyway, here you can see we import different packages and tools. and we specify which is the model we want to test, okay, and also the tokenizer that we want to use, okay. And you can see here, the reason you see the title is question plus context simple is that this model actually is suitable for the task where you specify a question and also the context. So the model will put your question into this workflow of the model, and to query is like querying the context. And the input to the model is actually to tokenize both the question and the context. So tokenize is to break down the sentence to word. If you consider word as a token, it is breaking the sentence to the word level. Okay, but the tokenizer may have different variations. Then perform inference is a step of asking questions. Okay, so this is a part we are going to ask the model, and this part is to use the torch function to actually extract the logics and find the answer span, and then decoding the answer with the last step. Okay, so and always check which is the exact definition of each sentence. So I'm just going to quickly pass to the test part. So in this case, I already defined both the question and the context. So this model will do one thing: asking this question with the context that we provide, and the model will output the answer. Okay, what is machine learning? A field of artificial intelligence. We can see here, machine learning is a field of artificial intelligence. This is quite an easy task, right? Okay. Let's expand this example. Now we involve also code. Okay, we first of all install the dependency, and we see, okay, this code is almost the same as the previous one. The difference is now I involve one of the functions to scrape a Wikipedia website about linear regression. I'm going to ask some questions around this topic, and we'll see how it performed. Then the question answering is similar to the previous one, and also the inference part. Okay. So now, by inference part, you see the description is ask a question based on the context of linear regression Wikipedia article. Okay, this is just to mention how the question and the context will be linked. Then we launch the interface of Gladio. So let's try one question. What is linear regression? Okay, and we submit. It is a very beautiful AI. I really like it. And you can see also in the large language model background and the different sources, you can see a lot of action plan. Okay, so let's see how it performs. It's not very quickly. You get an error. So I think it may be influenced by the code that I wrote after it. So I'm going to run it and launch the queue again. Okay. So I actually delete the runtime, clear all the mission here. Okay, select and delete the runtime and run it. Okay. So I set you test this notebook just to make sure that you can see. Okay, when you finish, you go to the next part, not run everything together. So, as you can see, ask what is regression? Just a linear related to a scalar response and a variable, and one or more explanatory variable, right? Or independent variables. Not bad, right? So they actually query the context that provided is in the Wikipedia page. As you can see, if you ask a model with the function call to get the online information, the output will be more abundant. Okay, the context will be longer, especially when you adjust the temperature. I'm not adjusting anything here. Okay, I just load the model and run it in a plain vanilla way, just quickly to view the effect or how the result is going to be shown. And you can see it's like a quick query, right? Not necessarily quicker than just search on the browser. Okay, but it's doing some query. So let's try another question. Okay, what are the metrics for evaluating linear regression? Let's see how it goes. As you can see, I see a hello bar to show the progress. Okay, and also by the means of error. Okay, is one of the metrics to evaluate the linear regression. You can also have R square and different metrics. Okay, okay, so far so good. So very quick view of the first model to query on the context. Okay, you can also try on your side. So now let's try GPT-2. Okay, in GPT-2, the basic structure is also like querying the words. The difference here is that I now add a widget. Okay, to actually it's shown in the output window, so I can input my my prompt. But as you can see, if you use the Gladio, it's more friendly, right? Much nicer to look at. So now here, GPT-2 is different because you do not need to give a context. Okay, so let's try here. Ask the similar question. Okay, what is a linear regression? And repeat the answer, and we're going to get a response. Yeah, you see, what linear regression is that regression is made between a given and blah blah blah. And see here, there's a result. It is a weighted shape. The weighted shape goes on. And let's try another. What to give linear regression. Let's see how it goes. You see, the first is the number of times the regression is repeated, and what I was expecting, right? Second method is number of times regression is repeated. It be like repeating and only changes some words. It is quite fun to test. Okay, just understand GPT-2 actually has trained with a different data set, different structure, how it deciphers the prompt in one give a response. Okay, it's quite different from the previous one. So let's try with Claude. Okay, so basically in Claude it will be shown better like this. Okay, at this part, let's see, we actually extend some of the parameter like temperature, maximum length, and so on. Okay, so my original hope is that we have this electronic navigation pane. Whenever you see, like in HuggingFace or in other place, you can see for each large language model, if you want to chat with them, you're going to see this parameter adjusting pane. Okay, and you can try to change different parameter. Okay, since the code was mostly generated by GPT, the interaction with GPT and the refinement. So if you go to the GPT-2 model documentation hosted in HuggingFace, you are going to see here, like the model generator, this function. Actually, you do not have so many parameters. So for GPT-2, I am not sure if all these parameters will be taken by the model. But of course, you can do different tests. You can either follow more strictly with the documentation, or you just ask GPT to generate this function. Both ways are fine, okay, to make it work. And if you want a more robust test, just try to modify this. Okay. This is not a final and rigorous version of the output generation function. Okay, it is only a reference. Okay, so let's see here. I do not change anything. Okay, let's see again. What is a linear regression? The good thing about the Claude is that once you click enter, the model goes out to generator. Okay, you go to phase of inference. Right? If you use the widget or something else, you need to click the button. You need to put more focus on the design of the device. But Claude seems much better and easy to get on. Okay, so what is linear regression? Yeah, it is more or less like before, and you see here kind of repeated itself. So let's see, we actually with some size, max length. Okay, it is shorter, but you can see the repetition is inevitable, right? So let's try matrix to evaluate. Right? Okay, let's see how it goes. Yeah, like the previous one, right? Now we're looking at the interface for user-friendly interface, we can test. Okay, here we use the BERT to play with the model to understand how, for example, before and more the model. Look at the old model. It's like examining the history of the large model, and you can get a better sense. So easy way is to get code fast and then try yourself, feel how it adapts to your user case. Another way is to take time to read documentation, publish the paper. It will take a lot of time. If you are not doing research about the models and you focus on your case, I would recommend you to test it in different sources. Okay, also sources where you see the models are hosted in a website, you try it, or you can try here with this notebook and adjusting some of the parameter and test it out. Okay, so you need to understand what you really want and what is your use case, and if such test is useful for you. Last thing is that I'm going to show you this failed example about the other model is a GPT-J 6 billion parameter version. Okay. It exploded because RAM. You see, here Colab has 12 gigabytes of RAM available. It quickly just exploded to all the RAM, so link is not successful. Okay, you can try to have enough resources, additional resources. Now, take a look at the note. The note is generated by GPT with referencing all the different sources. Of course, you can query the Wikipedia and so on. So if you want to try to take a closer look how it is designed, you can check it here. But rule of thumb, when you use the models, if you do not care about the design, the structure, computational, how can I say the structure, so on, you just check the parameters. The more the parameters, the larger the model, the harder it is trained, the more computational sources you need to train, fine-tune, or even doing inferencing. Okay, it's just a quick rule of thumb. And here we also have a comparison table like I introduced you in the beginning. So primary use case, let's check about GPT-2. It's about text generation, language task. Okay, how about BERT? It's extracting code, understanding task. And if we are using at home, for example, I would prefer to use the BERT model because you can set the context, right? You want to query a knowledge, maybe Wikipedia, quick source. If you want to like query a research paper, you can just pass a PDF and get information and ask model. But of course, its performance is much less ideal or advanced than the later model GPT-4 and so on. So we should have fun test all the models, which is tutorial is useful for you with citations. And the last one is that I want to see a different dilemma. Okay, that also shows different concepts and with citations. So far so good. Now let's check the log. Usually it's hidden. We can show the log. The log is usually about the last prompt that we give to the system. And you see, first of all, our query is changed slightly to a new one. Then there is an initial response, okay, two call and two outputs. Initial response will also have different citations. I believe the start and end are start time, end time, or start vector space code or end vector space code. And also you can see the citing YouTube video address and the title and so on. Then there is another two core to make sure that the response is according to our teacher style and just response to students. Then there is another output. Okay, in general, the agentic flow and the tool calling looks solid. And let's see the next one. Since I have refreshed the page, now I have redone all the queries. So the first one, I said, what are the laws about wildlife management and hunting? It actually gave me the answer. But the different thing is that now this time, there is not much citation. We can see here a very clear article and section, but for each sentence, there is no citation. And then I say, show me some recent cases. Of course, the cases are all historical ones, for sure. You can see the first one, the year is 2018, and it is in line with the description here because we are talking about the past court cases in Alaska. The last one, I said, summarize the common points of the cases that you mentioned. Okay, it actually summarizes the points here. We can see the tool call, the logs of the last query, and you see the tool call is to execute a summarization about the previous answers, then give the output. Okay, so this tool call is quite simple. So basically, for each prompt, you can check the log and see how the tool calling is working. So in general, I think either this demo we're seeing, this application, and also this package is designed well, but of course there are many rooms to improve. The first one is about the correct display of the timing of the financial data. That's the most important one. And also to show the sources of the recommendation. Then about the exploration of course, in general, it looks well. It would be better that we understand what the start and end means. So if it has more annotations, I think it will be easier to understand. For the legal assistance, of course, for each legal point, it's better with a citation for sure. And if it could also provide additional data analytical tool for the cases, it will be very useful. Because in the end, if we can have some common statistic summarization, it will be good. Okay, so let's see here. I asked to summarize common points. You give some text wording. I mean, if we could have some numbers, some charts, it could be better. That's all for the test of this package, this app. Wish you like it. If you have any question, feel free to let me know. If you like any topic you want me to discuss, feel free to let me know. If you like my videos, feel free to subscribe, and see you next time. Bye bye. channel again. This is episode 3 of Data Talk. This time we're going to focus on the pandas package of Python, which is a very important tool for us to explore the data and conduct basic data manipulation and some advanced operations. Before we go to the package introduction, let's see first of all one of the example of tabular data. We can see this data table is from the Iris dataset. Whenever you load the dataset to a data frame and you display, for example, in Colab, you can see the basic structure of this table. Most of the data analytics problem will start with the table. Okay, so manipulating a table is very important. The tools like Colab now has already integrated many additional new tools. Like you can see here, whenever you just directly load the data frame that you just prepared, it will give you suggestions on different plots. Okay, so it's easier than before. Okay, some of the code you do not need to write here, and also you can interact with large language model to help you code. It will be even faster. So let's take a look at the pandas. At the beginner level, as you can see, the first part, of course, in any environment, first of all, you need to install the package. But like in Colab, it is defaultly installed. So you just import the package and start manipulating the data. You can create a sample data by yourself. This is just a quick example. We have the name, age, and city. Okay, very simple example of the data table or data frame. Then, if we need to load the data set, okay, sometimes we need to load from a CSV file. So this is just an example. You can try to load your own file, and whenever we print the head, it will display the first a few columns of first few rows, like first 5 rows. And if you print the information, you're going to see it will describe a different column, which is a data type. Like a name is object, age is integer, and city is object. In the intermediate level, we might use the data selection and filtering functions of pandas. For example, like here, we select a specific column of the data frame and we print it. Or we filter a specific condition and to see the data points after the filtering. And also, we're going to, during our data analytics and processing, we always do the data cleaning, data preparation in different cases. Like here, we can copy a data frame to a new data frame, and we can also set a specific data to be null. For example, this one is in position 2, okay, in the age column. We set it as an NA, not available. And we can also filter the missing data. So basically here, and in some case, we might need to fill in the not available data with 0. And you can see here is the result after filling the NA field with 0. And we can also remove duplicates, drop duplicates, okay? But in our case, we do not have duplicates. So let's see the next one for advanced level. So here we can see another example. We group the data by city, and we take the mean of the age variable, and we can print the mean age by city. So because our data is quite simple, so like this one, Chicago, we only have one person here, so the mean is exactly the same as the individual data. Of course, you can expand your sample data to try different cases. Then we can also do some merge and joining data frames. It is similar to SQL language, but in Python, usually we can manipulate the data frames by using the Python language directly. But some of the cases, we might integrate the utilization of different language in different platforms. Here we see we create a new sample data frame. Okay, and we set it as a data frame here, and we merge the first data frame we set before with the second one, and we merge by name and from the left side. So basically it will match the same name, and to append the second data frame to the first one. As you can see, the salary data is appended to the right side. Okay, it's just a approach to the left. You can say it like this, and we can print the merged data frame. In this final example, we can see two important elements. One is apply, the other is lambda. So basically, in this operation here, we select the age column from the data frame, and then we want to apply a method to the selected column. And lambda will describe what we really want to manipulate this column. For example, here it defines a anonymous function, and in this case, it takes a single argument x, which represents the age column. So this means that it will use the following conditional expression to check if the x or the age is less than 30. So if it is less than 30, it returns young, otherwise returns mature. Okay, so it's just assign a tag to the numerical data. And after it scanned all the elements in this column and assigned this new character or new string variable, and it will finish the operation. Okay, so basically there is one function, lambda, and then apply this lambda function to this selected column. Eventually, we can print the transformed data frame and check the results. That's it. That's all I want to share with you in this episode. And in conclusion, please remember, Pandas is a versatile library for data manipulation and analysis, which is a very important tool for data science. And I encourage you to try different data sets, to manipulate them, and to check them. This could be a very important foundation for future statistical learning or machine learning courses, because after you prepare the data frame, you are going to apply different algorithm, train different algorithm based on this data frame. I wish you like this episode. If you have any question, feel free to leave a comment. If you like my video, feel free to subscribe, and see you next time. Bye bye. Hello everyone, welcome back to my channel again, and welcome to the fourth episode of Data Talk. In this episode, we're going to talk about the data visualization and Matplotlib, this important Python package to do the data visualization. First of all, let's check two examples of data visualization. This one is from the GitHub. You can see it is called Visualization Playground. The first one is a line plot where you can see the trend of two different data series. And the second one is a 3D data visualization. You can see in different setting or in different display, you can understand the different dynamics of the data. Like the first one, you can see clearly the trend and the position or comparison of each, let's say the position 0, 1, 2, 3, 4. And if the value is higher or lower for each series. For the 3D data display, you can see how the data is evolving in this 3D space. And in some cases, if you want to understand better like a gradient descent, the more advanced machine learning terms, using a 3D is a good way to understand how the formula, especially our loss function, is going to find the lowest point in a 3D space where we get the lowest loss. And in this web page, you can see different data visualization. It is very useful for you to understand the data, relationship of the data, and how to better visualize it. Okay. The second example is the HuggingFace Open Large Language Model Leaderboard. In this blog, you can see there are still many simple and very direct visualization of the data. You see this one is a bar plot where we compare the different score of different metrics, and you can see it never gets old. Even though it's a simple box plot, you can understand the comparison between different data series on different categories. It is very useful. Now, let's go back to the notebook. So basically, just like the previous episodes, I just try to condense the 3 levels of the package utilization into one notebook. But please remember, this notebook can be expanded to a very long notebook, because there are many use case, many utilization methods that you can think of. So let's see how this package could work. Let's see the first one. We just plot a line plot. So of course we need to install the dependencies and import the tool. You can see here we can design a very simple X and Y variable series and then plot them in the plot. You can see it's quite easy and the code is very simple. And then a more interesting part is that we can always customize the plots. So it depends on what you want to highlight. Example, usually if we have this dot with a dot line, it will give the audience a feeling that you want to emphasize the dot. So it depends on how you want to convey the idea. You want to convey the information of the data. So data visualization is important, and utilizing the proper tool to show proper way is also very important. So like this one, we just define the line style as dot. It will be like this dot line. It's not of course you can make the dot smaller. This is like a sectional line, right? But anyway, this will give you a different feeling than the first one. Then let's go to the intermediary level. Of course, like I said before, the bar chart can also be very important now, because usually the plots, either 2-dimensional or 3-dimensional, we can easily comprehend the 2-dimensional or 3-dimension visualization, right? So to compare the different categories, how their value differ from each other, bar plot is always a good option. You can try this code by modifying the sample data and see different results. So basically the code structure is very similar and very easy to manipulate. Then we can see this one is a scatter plot, where we can see the different data points, how they are displayed, how they are distributed in this 2-dimensional place. About subplots, it is very useful because sometimes you want one plot next to another. You both want to see the trend and also see the categorical difference. As you can see here, we can set 2 graphs, 2 plots next to each other, or even in a more advanced way, or in the future you can try to make a grid of the plots. Then for the advanced level, like this one, we can plot a histogram. A histogram is telling you how many data points is accumulated in a specific range. As you know, for many regressional models, there are many assumptions about the distribution of the variables. So one of the most common case is to see if the variable is normally distributed. Of course, you can also add a normal line, normalized line to see the bell shape, how it is positioned related to real data. So there are many use cases you can expand from this histogram. Then we can also do more advanced customization, like this one. We can, of course, say the style of the line plot, and we can also highlight as we want. Like this one, we say prime number is here, or you can just use different names to highlight what you want the audience to see. As I said before, data visualization is about conveying idea, is about finding the best way to show the audience how the data is distributed, is moving, and so on. The last one, let's see an example of 3D plotting. Of course, the 3D plotting now we have many ways. Not only this package, in other packages, we can have a dynamic display of the 3D plot. And you can see here, first of all, I think the most important part is how to construct this 3D plot space. Like here, we need to first create the 2-dimensional space, like 100 evenly spaced values between -5 and 5 for x and for y. So it's like create the base, okay, the lower plane of this 3D plot. Then we need to derive the z value. The z value, first of all, we need to make sure that's the grid. Okay, we already have an idea how x and y are expanded. Then we create this grid to actually make them link together. Then we use a function to calculate the z value. Like this one is a sine function based on the radial distance from the origin. You can customize it as you want and see different plots. And here you can choose different color style to make it more suitable for your audience and for you to explore the data. So we have covered this Python package in a very short time. I wish you can get some inspiration from here. For this introduction package is quite basic, or we can say quite entry-level stuff. If you like it, please leave a comment. If you prefer me to do something different, or if you have any suggestion, feel free to let me know. If you like my video, feel free to subscribe, and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Now I'm going to show you a project I just finished. It is about simulating the banking activity, or more specifically, commercial banking activity in Italy. But of course, the real-world commercial banking activity in Italy is very complicated. You have many procedures, many policies, and many interactions at a team working level, system level, with client, with regulator, with third party. It is a very complicated ecosystem. So in this project, I just try to simulate a simplified version. Okay, I want to simulate some activities and check if the program will produce some sensible results. If you saw my other videos before, I have tried to use agentic workflow to discuss about the bank compliance work plan and policies. Here, I'm not integrating the agentic workflow because I just want to see, first of all, if ChatGPT and other model could help me to program something to build a foundation, to help me to simulate, to see if some of the functions could work, if this workflow could work with GPT-4 and the GPT-4.1 model. And in the future, I would try to integrate the agentic flow to make the simulation more precise or more comprehensive. So first of all, let's see here. I have the process listed here. First of all, I just prompt the 4.0 model for me to use a Python code to generate the daily operation of a bank. Of course, I specified we take the deposit of the client, make a payment for the client, we disperse a loan for the client, and we also do some foreign exchange transactions and so on. I just give a description. So if you want to apply the way I use for this project to other projects, for example, you want to simulate how the factory accounting team would book different activities, you could utilize some of the ideas that I'm using here. Okay, so this framework, I start with a prompt with a description of the activities I want to simulate, could also be used in all other projects. And here, I would like you to pay attention. After saying what you want, after a brief description, this could be the best way to get the simulation results. Because days ago, I tried the simulation. If I use GPT-4.1 model only, it will get complicated and not precise. It's like a generic orchestrating agent. You can see different thinking process, but when you go to the specific point, it is very computational intensive to complete a task or design a framework. But if you use 4.0 model or smaller models only, you can make a specific code chunk to work, but it lacks the whole picture, the idea of the whole picture. So in the following process, you are going to see how both of them can work with each other. And again, like I said, this workflow or the starting point could be used in other projects. The interaction way of the different models could also be applied to other projects and also to the agentic workflow. For example, you have orchestrating specified for orchestrating model like 401. It is like the team leader. Smaller models like 4.0 and other models, I also use a 4.0 mini model to tackle some of the issues or debug some of the small problems. When they work together, you might get better results. This is the main idea. Okay, so now let's get back to the process of the prompt and the enhancement. Okay, like I said, the first step, I prompt the full model to get the process code. It cannot get a balanced booking records. So it can generate some random numbers like client 1 take deposit of 100 euro in the bank and make a payment of 50 euro. It can generate, it's like every single line is a record and you have different random numbers assigned to it. It does not pay attention to the accounting side, because at the accounting side, each booking, each operation, you need to have debit and credit balanced. Okay. After several trial, I test the model. It cannot give me the code, Python code to create balanced booking records. Then I tried the 4.1 model. As I said before, it struggled with detailed coding, and it might be more suitable for a small scale simulation. Not I mean like my simulation case, I think the banking activity I already included many details. Maybe it's not suitable for it to actually get accurate coding results. Okay. It is good you have the thinking process, but it may, if our standard is to get a zero-shot result, give the prompt and the 401 will give us a workable plan and a code. It might still struggle. Then let's take a look at the next approach. From step 3, I take a different approach. First of all, I use 401 model after the iteration. Okay, I put it at the first point is that 401 model is still important, but I use it after the iteration with 4.0 model. So basically at here, I first enhance the prompt in 4.0 model, then I use the enhanced prompt in 4.1 model. And during the process of debugging and so on, for example, I get the results like all the generated booking ledgers, CSV files are empty, or I cannot see the booking records. Okay, I see only transaction items but no booking records, or I cannot balance the credit and the debit. So each time first of all, I tried 1 or 2 rounds to talk with 4.1 model. If it does not work, I go back to 4.1 model and I come back to 4.1. And in the next step, I still use the prompt enhancement with 4.1 model and to go back to 4.1 model to do several rounds of prompt result test. But here, I can also use the result of 4.1 model to 4.1 model to debug. The reason is that after several tests, I find that if I use 3 shots, like 3 times debugging using 4.1 model, it may not be as efficient as get a result from 4.01 and the debug part of the code in 4.0 model. So I use this iterative process to put the 4.01 model result to 4.0 model to check to debug, use 4.0 model to generate Italian accounting rule list, and to check with the code generated by 4.1 model, because the complexity of 4.1 model is better than 4.0 model at some cases and more structured. Eventually, I also created an independent notebook to evaluate the accounting rules. So this process is going back and forth several times. During this iterative process, we can go back to 4.1 model to let it review some of the results generated. But always pay attention. As I said, the 4.1 model is better for orchestrating the whole picture, but the 4.0 model is more efficient to solve the individual problem or debug a code block. But if you still have the computational resource, you still have not yet reached the limit, you can try it. Okay. So I also ask the model to recheck the results. After all these iterations, I get preliminary results. It can simulate a booking record, validate the records, show some reports, build a database, and so on. I'm going to show you later with the latest version. Of course, the previous version, later I'm going to upload also in GitHub, so you can check the results. Just want to save your time. So what you can get from here is that you need to have a orchestrating model to work with a smaller model, more specific model. You need to think about the process and how to tackle each single bug. Do not rely on only one model, either in agentic flow or the current flow I'm showing you. Then I would say for this project, there are several possible improvements we can do. First of all, we can do agentic workflow with accounting rules and build a RAG system. So the agents have always quote the accounting rule and make better accounting decision. We can also design a robust database to handle the data management and report generation. Of course, in the production environment, this is the case, and this is a must condition, because the management of the database is a very complicated issue. Then we can also improve the generation of client, regulatory, accounting reports, along with audit capabilities. This would be a step to approach a comprehensive simulation of the organizational information flow of a bank. We can also simulate a Swift message exchange. This is a more specific topic because Swift messages are used to make client payments, make banking institution communication. It will be very useful to use it, to simulate it, and you can also link it to some anti-money laundering screening system and so on. The last one is about some detailed logic. Although I already tried to use more models and also my personal expertise to make this program work, make this notebook work. However, there are still some logical designs we need to improve. Like there are still some FX discrepancy about booking side is small, but it may always let your financial report not balanced. With this enough said, let's go back to the project. So first of all, we have requirements file. You can use it directly to install the dependencies. If I miss something, just add here and run it in your notebook. Okay, and also make sure the requirements are in the same directory as your notebook. Okay, just for the organization purpose, make it more clear. I now put the latest successful results in this folder. Is test 8. First of all, let's see this notebook. So basically, I put everything inside of one code block. The reason is that during some iterations with GPT or the coding model, I find if we have so many independent blocks, it may not be easy to quickly move the code from here to another interface. But this is just my personal choice. You can also do it block by block if you prefer it to be clearer. And here is the version that I put all the annotations or the explanation of each single line. I'm just going to share with you the most important part. First of all, you can see here, the first function is to initialize the database. This design of database is very core for the banking operation. As you can see, GPT already does a very good job to design this database. But choosing SQLite or other database is your choice. Okay. But the first thing you need to do is to initialize the database and to see if all the fields are matching your demand. Then, after initializing the database, we start inserting the clients and we keep connecting to the database file. And each time when we finish a change, we commit the change to the database. Then, about record ledger entries is the function where we insert the different information inside of this booking ledger. And here is the deposit function where we simulate the case where we put deposit to the client or from the client. And here, this function is withdraw function. Is client withdraw the money from the bank. As you can see, these two functions are very similar. And the important thing is that when you check this code, try to find their difference. So you have a similar rule to follow the sequence, but you also have some details that you need to pay attention. And here, you can see each booking either is deposit or withdraw. We need to connect to the bank notional account and the client deposit account. If you are not a banking professional or you ever worked in a financial institution, do not worry. If you do not understand what is notional account, you can simply check it. It is just in our system is like a booking sign which identifies our account opened in another financial institution. But I'm just going to focus on the code at the moment. You can just remember like this. This pair of booking actually happen to complete this transaction. Whenever you book a client deposit, you need to book also the notional account. And here, simulate a 1-day operation. So I have a simulate 1-day function and also generate daily ledger function. So in this function, you can see it actually retrieve the client's ID and the currency, get these results, and generate a random choice of different transaction with a random number and give a feedback of this transaction. And for the booking side, for the generate daily ledger, is actually to assign the accounting information to this transaction. And after the completion, we're going to have a CSV file, as you can see on the left hand side for every day. Then we simulate 1 month. So simulate 1 month will first of all identify the time span that we want to simulate for this whole project. Okay, it is called 1 month because I only want to simulate 1 month of activity. It will call this simulate 1-day function to generate an activity and to generate a daily ledger and do it one by one, day by day. Then we generate monthly reports using this function. As you can see, generating reports using SQLite structure is, personally speaking, I think this is the easiest way to construct a report. And as I introduced at the beginning, have a very well organized database is very essential for your workflow design. So as you can see here, we have assets, liability, balance sheet. Okay, all these items should be generated in sequence. And you can also see here, we have a total debit, total credit, and to check if they are balanced. Okay, just to give an idea if it is balanced. So a more robust way is that when it's not balanced, how do we make it balanced? I would suggest to, in the future, for example, if you want to improve this project, you may try to add the audit rule to audit the results, give suggestion, and let another agent to amend this booking record. That would make more sense. But for a prompt-based coding generation and the system design, I suppose there is a limit. We cannot go more detail because, as you can see here, it is a very small problem compared to the whole project, right? It is to check if the ledgers are balanced and make correction. That would make the project more complicated and make the prompt more complicated. And I do not think for one model or for a model can handle for such a big project and considering only 0-shot accuracy. But for agentic workflow, I think it may be achievable to design a role to audit the result and another one to give suggestion to change the record. Then we initialize this function. And we also visualize the data, transaction distribution, client balance. Okay, and then we see the plot. Okay, let's see. This is a simplified version without many descriptions. Let's see the results. So basically, we see many debit credit summarization on daily basis, and how many entries of the booking was done at that day. But almost all all the first several 1, 2, 3, 4, 5 records are not balanced. But it does not suggest a solution. This is the limit of this program at this moment. Then you see here, we start to see the ledger is balanced. I would assume in this case, the booking logic is simpler than the others. For example, you just take a deposit and book both the client account and notional account. Most simple case. You just get a balanced ledger. But whenever the transaction complicates, you cannot balance. Then, let's see here. Yeah, every day we have the booking records show. They will also have the financial report. It's nicely displayed, much better than my previous tests. Okay, we can have the both a balance sheet and also the income statement. But as you can see here, if you try to say asset equals liability plus equity, is not balanced. Okay, and also here for the net income. The net income part, luckily, the final result is correct because I double checked before, but the layout is not a traditional way. Because usually you don't see left-hand revenue, right-hand expense, and you calculate net income for each row. Not like this. It should be horizontally organized, and eventually we add some item, subtract item, get results. And also we have the cash flow. Right. Yeah. So in general, this report's layout at this stage looks okay. And also it calculated the capital adequacy ratio. Okay. Then we can see this transaction list. This is all about loan for the calculation of a capital adequacy ratio. Then we can see here the client ID, and I think this is their account balance. Okay, I think loan account balance here. Then we see the transaction type distribution. This is nice. We can understand how many transactions in each type. You know, in a financial institution, usually if you see some change of the transaction type for the client or for the institution, is a very important signal for you to manage the operation more effectively. Then we see total debits and credits. This is much better than the previous version because in the previous version you can see there is a big gap between everyday total debit and total credits. So it means that the whole program is not very accurate. Eventually we can see the client balance shown in here and with names. Of course these names are simulated. So far so good. So basically we have all the ledgers simulated, we have the reports generated, and we see the graphs. Then let's see another file. Is checking the CSV file and the reports. As you can see here, we have two code blocks. The first code block is actually to check two daily ledgers, one large exposure report, balance sheet, income statement, suspicious transaction, and use the tab organized way to see the results. And let's see here. Try to run it again. Here we go. You can see all the ledgers are displayed. This is very close to the display of a commercial bank operation system. Okay, you see entry ID, you see the date, you see transaction ID, and you see the booking, one debit, one credit. Everything looks perfect. Then day 2, but always pay attention to the FX transaction because I suppose some of the discrepancy comes from here. Because whenever we are talking about FX transaction, not only that we change one currency to another one, we may also charge fees. Okay, like here we have the FX gain. We charge the fee or we have the margin of the exchange rate. But whenever you calculate this one, you need to have a currency tag. So at this moment, I do not have it. So there will be a discrepancy. For example, the whole debit sum and the credit sum of this transaction may not be equal. Large exposure, it shows some results. Monthly balance sheet looks okay at this moment, but as I said, it is not balanced. Monthly income statement, as I said, the format is wrong, but the result is okay. Suspicious transaction. I actually prompted to ask to create some simulated description for some client transaction where it seems suspicious. So we can put it in this table, report to the regulatory body, like in production case. But as you see here, the description is only about the the direct nature of this transaction. We are not saying that this one is related to a political exposed person and so on to make it suspicious. So the simulation at this step is preliminary and not what we wanted. But here, from the tabs of the data checking, I think this is a good way for us to inspect the simulated data here. Then we can also open this bank simulation database. This is a database file actually created by SQLite. We see in this database it is organized quite good. Okay, we can see the database format, and we can also see this data frame format to understand the client balance. Okay, we have as you can see, this program simulates different clients, account type, currency, and balance. So, looks okay. I do encourage you to try to apply this to your own use case and simulate the operational workflow of any organization or any type of workflow you want to simulate. Okay. At this moment, we do not have agents. We only have a prompt technique working with different large language model, improve the coding results iteratively, find ways to interpret the result, and eventually have this initial program working. But again, take a look at the general flow. I prompt for model a lot of times, do not get the good results. I prompt to for one model. I realize it is more suitable to get a zero-shot result for short scale model. Then I enhance my prompt with the for model, go back to for one model to build a more robust structure. Then I iterate each single issue with for all and for one model. The choice of debugging in for one model or for a model is totally based on you. If you want to debug a single block, code block, better use for all. But if the context grows longer, you want to still keep in track with the previous records, you need to use for one model. But always make sure that large language model do not shorten your code, do not alter your logic. Make sure that they are always in line with your design. So in this process, I debug some issues. And then I did a further prompt enhancement with for model, incorporate the latest for one results, generate relevant context with Italian counting rules. It is kind of a manual rag. And I also thought about a way to evaluate the notebook based on the counting rules. So we further enhance the results. Then we review the results, also with the for one model. And eventually we get this final program working. So we can see the booking records and also see the validation. Okay, validation is a separate notebook. As I said before, the possible enhancements, there are many, and I think this could be a good start. I wish you like this video. If you have any question, feel free to leave a comment. If you like this program, feel free to utilize it in your use case. If you like any of the contents in my channel, feel free to subscribe, and see you next time. Bye bye. Hello everyone, welcome back to this episode of Data Talk. On this episode, I'm going to continue the introduction of data visualization. So before I go to the notebook, let me show you just two websites which we can see the different user case of data visualization. The first one is ourworldindata.org. You can find a wide range of world data in this website. For example, now I'm seeing the display of explore data on metals and minerals. You can see there is a line graph, line chart, and you can also play time lapse. It's very well designed and a very clear display of the data. And you can also choose the heat map on geolocations, see the original tables, choose the data series that you want to visualize, and so on. And there are many other options where you can explore different data display, data visualization. The second one is a neural network playground. This is developed by TensorFlow. I really encourage you to try it, because here you can see multiple elements. You can see the visual design of the training process of a neural network. You can also see the visual display of the outputs. Now, as you can see, I have run this page for like one night, more or less 8 to 9 hours till now. And now it has run over 100,000 epoch. So in here, you can both try to change the different hyperparameter, different feature, different hidden layers, different neuron design of a neural network, and see how it goes to the final output. You can also see here the test loss and training loss very clearly. So these two websites can both show you how important it is to visualize data, because the more visual we get, the more direct sense we can have about either training a model or the data distribution or the trend of an event or a variable. So now let's go back to the notebook. So today I'm going to share with you some of the use case utilizing Seaborn, another package from Python. I have listed some examples from beginner level to advanced level. Of course, please bear in mind, this is not a very comprehensive introduction. So which means that the separation of the level is my personal opinion, and there are many more use cases that you can expand from here. So I wish this would be helpful for you. First of all, let's see, before we visualize any data, it's better that we see the data, okay, to print the data head. So this tips dataset is actually inside of the Seaborn package. Okay, For utilizing any package, we first import and then do the preliminary step to visualize the data frame or to visualize other characteristic. You can also use different functions like description and so on. So now we understand that we are seeing this the bill, or we can say the tip per bill dataset. And we can see there are many variables here. We can see the total bill number, the tip number, sex, smoker or not, which day of that bill, the time is dinner time or lunch time, and there is also size. So the size variable, I think, is about the table size for 2 persons or 3 persons. And one of the simple plots is scatter plot. You can see the relationship between the total bill and the tip. So basically, you can see it goes from the lower left to the upper right. This is a quite positive relationship. When you pay a higher bill, your tip number goes up. But it is also very important to note that the scale of the different axes are different. Here, we see another type of visualization is utilizing the bar plots and box plots. So in here, in this bar plot, I put the x-axis as day, which day was the bill paid, and also the tip value as y-axis. As you can see, we can see the average value of each day. The tip value could reach to the average tip value could reach to which level as the edge of this bar, and also we can see a fluctuation range, okay, of this value. It is very common also in the case when we evaluate a large language model. You can see different reports that when we evaluate, for example, if this one is about the precision of the math task, okay, the precision level, the average at which level, and fluctuate to which range. So it's quite useful. And more precisely, that black line is the error bar. It actually is a 95% confidence interval, which you can use it to see the distribution of the data in a very quick way, in addition to the bar plot. And I add a note here. You can check in detail how you can utilize it. And especially when you see if the distribution are not overlapping between the different categories, which means that they are statistically different if they are not overlapping a lot. If they overlap, which means the distribution are very similar from each other. Now let's take a look at the box plot. Okay, the box plot is also very important for us to visualize the distribution of the data. So you can see for each day the tip value range from which number to another number. And if this one is not very direct, or you still have doubt to interpret it, for example, you don't know about quartile and don't know about outliers, another way to visualize it is to put the box plot horizontally and the histogram of this series next to it, and you just mark the Q1, Q2, and Q3, so you can see the general distribution of the data. Okay, so for each day is different. Whenever you see there are dots, which means there are significant outliers, okay, less outliers, almost no outliers. You can also see in Seaborn how they put the outliers. Okay, so you can see the dots represent tips that fall outside the range of the whiskers. So you don't see it in every type of distribution. Only some distribution which we have significant outlier defined by Seaborn, we are going to see these dots. Now let's check the pair plots. The pair plots, you can see the pairwise distribution. For example, I want to see the relationship between the size and total bill. I can see this one. So I can see roughly their relationship, right? And in here, inside of it, whenever you see the tips overlap with tips, like here in the middle of the graph, you can see the distribution, histogram of tip. So it's a range of its value and the distribution between of the different value in a histogram style. And here we can see, we can also show the heat map of the data, but pay attention, heat map is only available for numerical data, so which means that whenever we have categorical data here, we cannot visualize it. So as you can see here, I get an error. So in order to solve the error, first of all, I inspect the data frame again. I see there are many categorical data like sex, smoker. There are many ways to solve the issue, or we can say to encode the categorical data. As you can see here, if we use pandas, we just transform it to dummies. It will be like this. So for each categorical variable, for example, is male or no, yes or no, is true or false. For sex female, true or false, and so on. And for the date variable, it actually separated to 4 because we have 4 types of the date choice. So if Sunday is true, the others are false. Okay, this is a quick way to transfer categorical data to the dummy variable where true is 1, false is 0. And we can also see the lunchtime and dinner time as dummy variable and encoded with true or false. There are also other ways to encode the dummy variable or categorical variable, and you may choose and try it. So basically, this kind of coding is also called one-hot encode. And after this transformation, now I can display the heat map. As you can see, we can see this correlation table. One variable is correlated to another variable at which level? More positive, which means that they are more positively correlated or negatively correlated. Let's just take one example. So basically like this one, we see time launch. Okay, and also the day Thursday, and it is very positively correlated, 0.92. So which means that on that day, most people would choose to have lunch, okay, in this distribution. And you can also examine the different one. For example, if in this group, if female or male is more prone to be a smoker, and so on. We can see the distribution of data, relationship of the data, and also to interpret it to see some patterns. Then you can also see here, I print out the correlation table. You can see only the numerical display of this data. And if you do not want to see the categorical variable in this correlation table because you think it's less useful, you can just delete these features and you only see the numerical variable, how they correlate with each other. So basically we can see here almost all the variables are positively correlated with each other. Then we see here there is another type of graph where we can display, and here we can see the comparison of different category in a scatter plot pattern. As you can see here, we have sex as male, time as lunch, the male in dinner time, and then we can see that the tips which a male would give during dinner time are more scattered across a longer range, and we can see there are more generous tips happens from time to time, not very often, but there are some outliers very easily to be identified. And we can also compare horizontally, so we see the sex as male or female, and both at lunchtime. So their tipping behavior are quite similar. And we can see female actually has a tipping behavior more consistent, either is lunch or dinner. But if we compare the female with the male at dinner time, I would say the female tipping behavior is relatively more conservative. They tip less because you do not see outlier, or we can say they don't pay the tips very distant from their average behavior. So you can see a lot of information here. In this type of grid, you can compare them in different ways. Then we can see here there is a violin plot. This kind of plot, you can see the distribution of data across different categories, which is also very useful. It's more useful when you can identify where most of the data is not distributed around the mean. So in that case, you need to pay great attention. So which means that the distribution are at the two sides of the total distribution, not in a bell shape. So bell shape usually is close to the normal distribution, as you know, where we have the mode, mean, different parameters close to each other. But if they are very distant from each other, you may need to take a different perspective and examine the data differently. Okay, so just in conclusion, I think the Seaborn is a very useful tool. You can explore more options in the official documents and try your use case. And as I said before, data visualization is very important. So please keep exploring and try different tools to visualize your data. I wish this episode is useful for you. If you have any question, feel free to leave a comment. If you like my videos, please subscribe and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today we are going to explore one of the most recent developed tool. It's called the Notebook LLM. It's developed by Google. So if you search on Google about Notebook LLM, the first result is it. When you open this page, you can see here, you can click Try Notebook LLM, and below you can see there is a quick demonstration how you can utilize this tool, and of course some snapshots, basic layout, and so on. Now let's go inside and see how it looks and how it works. So we'll click Try Notebook. These two, the first two you see, is what I have tried before. There are 4 examples here. You can click each one to see how it works. For example, the first one, Introduction to Notebook LLM. Let's click it. So basically, when you're inside, you can see that the left-hand side, you have a lot of resources, which was previously uploaded to this notebook. And here, if you see the notebook guide, you are going to see the summary. The resources discuss about what. Okay, this about capability of Notebook LLM, about this product, and this tool is utilizing AI with document organization. You can upload all the doc types mentioned here on the left hand side become your resource. Then it works like a tool calling. Okay, when you type your question or what you ask for here, it will query these documents, and it's like a tool calling on query documents. And this is also very similar to the RAG flow, or I suppose this is just a RAG built on this platform. Okay, so you can call different resources and cite the information and combine together to give you an answer. As you can see here, the tool provides summaries and key topics from these documents and allow you to ask questions. So this is a very user-friendly platform where you can do the query on documents, asking questions, and so on. And it can also generate different outputs like outlines, study guides, timeline-based on uploaded documents, and the sources cover a wide range of topics related to the product, from its basic features and limitations to its potential use in research writing, meeting transcripts. And here you can see there is an audio overview. Okay, audio overview function where you can load the conversation. What does it do? It actually transform this notebook into a podcast. Okay, and for different documents, you can now easily transform to the voice version where you can listen. So this one is the default example. Let's see. Ask one question. How can I better use this tool to study any topics? Let's see how it goes. You ask this question, it actually does a query to all the documents. I think first of all there is RAG. Okay, there is a RAG mechanism behind. So the system will go to query these documents. Then there might be also the agentic workflow. Basically, there are some agents to do query, to do citations. Okay. Of course, I do not yet find any specific design documents about this tool. If you're interested, read their documents. Okay, let's see the results here. Okay, so here are some tips on how to better use this tool for studying any topic. Okay, upload the material, focus your study, utilize notebook guide, ask specific questions, maximize note-taking features, leverage, curate, and create, use citations, advantage of suggested actions, understand limitations, provide feedback. So everything looks good. You can read the different points on your side, and for example, when you hover above each of the citation number, you can see the citation source. So it's quite convenient. When you click it, okay, it will show the source on the left-hand side, highlight where it gets the relevant information. Okay, it's very good. Now let's go to another customized example. So if you know about the massive data set course of Stanford is in this web page. Let's try to do something about the map radius. Because the book is a bit long, let's try to use the slides first. Okay, I just copy this link address and I'm back to the interface. Okay, and I'm going to create a new notebook. Okay, and here I just there are several choices. Okay, you can upload the physical PDF. Okay, save them in your local drive. You can use Google Drive, link, or paste text. Okay, I just going to use link and insert. Now it actually go inside of this link, and eventually when the system identifies this is a PDF file, it actually get the PDF file to this source list. And now you can see it already give me a summary. Okay, this document taken from Stanford University lecture series on mining of massive datasets focuses on which kind of problem, right? So it's quite accurate, and there are suggestions and questions. What are the key challenges and solutions for designing a distributed computing system for large-scale data mining? Okay, and here you can also generate a deep dive conversation. I do not show you how it sounds like now because I want to make sure that my created content on YouTube is mostly made by myself. So if you want, you can generate, and it will say take a few minutes to generate this conversation, and you can listen to it. It is a podcast. There are two hosts in the podcast. They talk with each other. It's very realistic. So I encourage you to try it. If it helps you to learn, of course, it's a good thing. If you still prefer to read, you can query anything from here. Now let's say, okay, what is map radius? Okay, this is a very important concept. Let's try here. It will query the document. Of course, in our case, this is a simple query because I only have one document. If you have multiple documents, it will query multiple documents. Okay, so map radius is a computational or data manipulation model that provides an elegant way to work with big data. We can see here citation from the different slides. Of course, this is a slide saved in PDF format, so there are some not well organized display here. And we see this point number 2. Yeah, it shows the source, and then you can see how this mechanism works. Okay, map takes a key value pair as input and output, a set of key value pairs. Reduce takes all value associated with the same key and process in order of V. Okay, looks okay. So this is a great tool that you can query the document, get summary, get insight, and at this moment, it is set as experimental, so it is in a phase of I think a test, but it's free. You can try it. I really encourage you to do it, and I wish you use this tool to enhance your learning process and the journey. Okay, then eventually we can also share this link. I think this is where you can share with others. I think these people, let's try. Okay, so yeah, I can share with others. This is like the Google Doc sharing process. Okay, so everything looks good. I wish you like it, and if you have any question, feel free to ask me. If you like my video, don't forget to subscribe, and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today we are going to test the new Llama 3.2 models with different tools. The tools we are going to use include LLM Studio, Llama, Grok. So basically we are going to test 3 use cases. The first is to ask a large language model about concepts and verify the concepts. The second one is to test the coding capability of both models. Then we are going to utilize the agentic workflow both of Claude AI and also the AutoGen, and see how they can interact with these models. So before we start, I just want to mention to you the models I use. Although they are all Llama 3.2 models, they may have different quantization model. a simple way to understand is how these models could be compressed to a smaller size, so you can adapt to different platforms, different machines, local machine in the cloud, and so on. For LLM Studio, I'm using the LLM Studio community versions of the two models. Then about Llama, I just do Llama pool of the third and fourth models you see on the list. You can check their specifications in the official website. The last two are the official models from Meta released in HuggingFace. I'm not using these two models, but if you are interested, you can check them on the HuggingFace website. And for the Llama 3.2, 1B and 3B models in Grok interface, you can check on their official documentation, see the list of the models and the specifications. As you see here in the HuggingFace, the official release of the Llama 3.2 1B model is in this page. This is a 3B model, and you can see if you want to download it, you need to agree the community license agreement and to do the login. And in the Llama, you can see the Llama hosts the Llama 3.2 model. You can choose here is 1B model or 3B model. You can see the different specification and descriptions here. Then about the ML Studio, we are back into the HuggingFace. You can see we see LLM Studio community version of Llama 3.2 3B and the LLM Studio community Llama 3.2 1B model. Last but not least, you can see Grok Cloud documentation, models, and you can check all the models hosted in Grok. As you can see, Llama 3.2, all these models are already hosted in Grok platform. And more interestingly, if you want to further test like a 11B model, 90B model, they are all available. So next, you need to make sure LLM Studio is installed in your local machine and all the models are installed for you to start testing these models I mentioned before. For Llama, you can install Llama in your local machine and then pull the models so they are ready to be used in inference mode or server mode. And for Grok, you just need to apply for the API and choose the models accordingly. After you install the LLM Studio, downloading the model to be able to load in later stage is very easy. You just choose the search function, input Llama 3.2 and click go. It will show you all the results. Just to be safe at this moment, I chose the LLM Studio community versions because you see there are so many versions, and in each version you can see the different quantization level. So I choose the LLM Studio community version and use the largest model available. Because the model is already very small, I don't think it's very necessary to just compress it to a smaller model. So I use the LLM Studio community for the 1B and the 3B, as you can see here and here. So you can also open the browser to see the model card in HuggingFace. As you can see here, the model card are shown in the HuggingFace pages. You can go here, Playground. In here, you can test the different model simultaneously, or you can go here, Local Server, to load the model. In here, in the Playground, you just need to select the models you want to load. I have the 3B, 1B models, Llama 3.2, and just load the model. Then you can see the model is successfully loaded. And here you can see if your local PC resource does not allow you to load the multiple models, it will give you a notice. Loading additional models is temporarily disabled. Unload models to free up system resources. So in my local machine, I cannot do them and test them together. So if you can do it, you can use this Playground to do it. Then you go to a local server. In the local server, you can load any model you want. For example, if I want to load this model, after loading, you are going to see it is ready. Make sure that you can choose a proper server port to avoid the conflict. And the different settings, for example, how to utilize the inference structure to LLM Studio are all listed here. You can check on this part. But since the interaction with LLM Studio and Llama in local environment is relatively more slow, so I just show you this option. If you want to try it, you can try it. So in my later tests, I'm not going to use ML Studio as a server in local interface. And to prepare Llama and the models in your Llama. First of all, you need to install Llama in your local environment. Then you can pull a new model from the Llama server. Please pay attention, 3.2 default model is 3B model. So like you see here, the first time when I pulled the 3.2, it actually gave me the 3.2 model, although here it does not say it. It is actually the 3B model. Then if I specify I want to pull the 1B model, it will pull the 1B model. Then you can see this is the new result. You got the 1B model and the 3.2 latest. And if I pull 3.2 model 3B version again, the name will be changed. So if you pull it with the correct name at first, you will not be confused about the names. After preparing these models, we can utilize different agentic flow to interact with Llama. And to utilize Grok platform to access different model, you need to go to the Grok Cloud and prepare your API key. After you prepare your API key, you are going to utilize in your code. I'm going to show you later. So basically, the cloud case, the Grok case is the most simplified case because you do not need to manage all the models locally. So the first question is, what is large language model? Second one is, what is linear regression? The last one is, what is loss function in machine learning? Let's try them out. Because my local machine does not allow me to do testing on two models simultaneously, I'm going to do it one by one. So now I'm in the AI chat, and you can choose a model here, so the model will be loaded. We are going to ask the questions previously. As you can see here, the model is generating the response. So just to avoid you to read this slow generation of results, I'm going to show all the results all together later together. As you can see here, I have two chats. One, I talk to 3B model. The other, I talk to 1B model. And you see here, this one I show you is from the 3B model. But since now I have not removed the 1B model from the loading pane, so you can see here, whenever I go back to the 3B model chat, it will notify me, reload this model. So let's just check the results. So first one is what is large language model? Large language model is a type of artificial intelligence designed to process and understand human language at a scale that was previously unimaginable. These models are trained on vast amounts of text data, which allows them to learn patterns, relationship, and nuances in language. And you can keep reading, and it also shows some of the model examples. Okay, the Transformer XL, this model I'm not so familiar with, but you can check. In general, it is summarized very well, and also show you the bias and fairness. Can show bias lead to unfair outcomes, and it also give a notice. Okay, there's a potential job displacement, which most people are worried about. Yeah, looks okay. So what is a linear regression? I'm not going to read every line with you, but I noticed one error is that it showed also the non-linear regression. So when I'm asking about linear regression, it gave me some explanation of non-linear regression. So it actually adds some irrelevant information in the answer. But in general, the other part looks okay. Let's see what is loss function in machine learning. So it said loss function is a mathematical expression that measures the difference between predicted output and actual output in your model's performance. It serves as a crucial component of training process, guiding the model to minimize the error or discrepancy between the prediction and the true values. It could go deeper, but at this moment, if you want just an immediate impression about loss function, it's okay. But of course, the loss function, you can have more points which you add to the concept to help you know the whole picture of the loss function in different scenario. But for a quick answer, looks okay. And it also shows different loss function. Mean square error, cross entropy, binary cross entropy, looks okay. And there are also some common use of loss function for regression and classification task, looks good. Challenges: choosing the right one, overfitting, underfitting. And also here, the best practice, regularization, hyperparameter tuning. So for hyperparameter tuning, I'm not quite sure because I think it's quite different from the loss function because it's another part of just in the model structure. In the future video, I'm going to show you some of the example how we tune the different parameters of the neural network and to see the different results. Then model evaluation. In addition to loss function, use other model evaluation metrics to get a comprehensive understanding. So it actually said the loss function is part of the evaluation matrix. This is wrong because loss function is the function where you gauge the error. Okay, let's say it this way: to gauge the error of this model, you want to minimize it. But the loss or the accuracy are the metrics you want to evaluate. So I would say this comment is wrong. So let's take a look at 1B. The results from 1B model is quite out of my expectation. For example, the first question about what is a large language model, it gave me a quick concept, type of artificial intelligence designed for natural language processing and so on. Okay, looks okay. And additional information, training data, a massive amount of text data, application. They have a lot of application, looks very well. And for example, it gave me this code block. This is out of my expectation. I did not ask for the code, but it gave me the code. I have not yet tried the code, but in general, the structure looks okay. So you just load training dataset, input in the model to train the model. And it also gives you the key points to note about the training using of PyTorch. Looks very good. It's like concept and practical part. It can generate such information for you. Then let's see what is linear regression. Okay, give me a very short description. And it actually just use 2 words to representing the linear regression. I think it makes the context window shorter. And in general, it looks well, especially here, common application. And also the code is quite different from the 3B model. And you can see here is a quick example of the linear regression. It looks okay, but of course we need to run it to see if the results is okay. But in general, this sample array and apply linear regression on this sample array looks okay. Okay, so also some key points to use. And importantly, the model uses OLS to estimate the coefficients. Looks okay. What is loss function in machine learning? Let's see. Measure difference between the outputs. Okay, the same as 3 model. The matrix that indicates how far off the model is from achieving the desired outcome. So again, loss function itself, it is a function, it is not a result. If we are talking about the loss value calculated from the system, of course it can be a matrix to evaluate the model. So I do not like this answer. And minimize the difference, reducing the error, and optimize the performance. Okay, looks good. So there's a MSE, cross-validation accuracy, mean absolute percentage error. I need to check some of the concepts because some of the concepts I don't use very frequently. I also need to check its accuracy later. And here we can see it gave an example about the cross-entropy loss for classification problem. So it actually gave a sample data set with class 1, 2, and 3, and they use a cross-entropy loss to measure the difference of the outcome, and it will print the loss value. In general, it looks good, but again, you need to run the code to understand. And we can see there are key points to note. Okay, so in general, the quality, the precision of the model about concept generation are still doubtful because it may have some misinterpretation of the concept. But 1B model seems to put the answers more concise and give you actual examples. So this is the first impression I have between these 2 models. Now let's test the coding capacities of the 2 models. So first of all, let's see the 1B model. The 1B model, the first prompt is a Python code for snake game. Okay, it just define a function and run this function. Okay, and it also gives some notes about this function. But the most important part is to run this code and see the results. I'm going to show you later. And this is the results of use the Y-Finance package to get Apple price. I want 1 month price data, but from here I already see that it is not getting 1 month data because there is an important variable is the duration was not set. Then use Python to scrape Wikipedia's SP500 page stock list. And in general, it seems okay, but I need to try it to test the code. Then let's take a look at the 3B model results. It is more comprehensive. As you can see, first one is about the snake game. It is well structured. First of all, it defines some of the variables which we are going to use in the game, and then use the class, the snake game, and define different functions. Eventually, we run the game. Okay, and it also gave some detailed instruction how to use this file and so on. And also the Y finance part, it sets this parameter as 1 month. So I assume that it will get the results. And about scraping is more or less the same as a 1B model. And without reading all the context, of course, you can try on your side. Let's see if all the codes can be run with successful results. As you can see here, I copied the code to my Colab notebook, so I run it in Colab environment. Of course, you can also choose to run it in your local environment. So let's first of all check the 1B model. First, the code is a snake game, and we get this error: print board is not defined. So basically, we just go to the first few lines, we have an error. Okay. Then about the finance, Y finance package, it actually gets the price data. I think this is a current market value of Apple without giving me the 1 month price data. About the Wikipedia SP500 list, the result is empty. Then we check the 3B model results. First of all is the snake game. It can be run. Actually, in Colab environment, it actually shows me this interface. Whenever I choose the direction, it just prints out the new layout and asks me to choose again. So, but you cannot hit the snake by itself, or when you go to the border, you get an error. So there are many things that could be improved, but at this moment, at least it can be run and you see some results. I would say it is okay. Then we see this Y finance package utilization. We get the 1 month closing price data of Apple. And last task, we test the scraping of the Wikipedia page. It actually gets an error. Non-type object has no attribute find. So the larger model, 3B, actually wins this time by successfully running 2 code blocks. Okay, although one code block is failed. And the 1B model actually gets only 1 partial result about stock price, and all the other 2 codes failed to perform. And now let's go to the last topic about agentic workflow with Llama and Grok. So we are going to utilize both the AutoGen framework and also the Crew AI framework to do different tasks. Now let's check the results. So on the left hand side, you can see this is Llama 3.2 3B model hosted in Grok. And on the right hand side, I chose the model Llama 3.2 1B hosted in Grok platform. So basically, first of all, we need to install the AutoGen package and the Grok package to utilize both tools. And I'm just go through the most important part. First of all, you need to properly set up the configuration list. Okay, so I just designed this drop-down list to allow you to choose the different models so you can test. And the first agentic workflow example is taken from the AutoGen official website. Is a coding task. So basically, the agent group chat will eventually get a code block generated and executed to see the results. You can check the example in the official website. So I'm just going to show you the results directly here. So in the interface here, I just choose a model. Like you see here, on the left hand side, I chose the 3B model. On the right hand side, I chose the 1B model. And both work fine to generate the code. Okay, the task is to count the number of prime numbers from 1 to 10,000. Okay, so both of them get the code working. Although you see the variable name on the left hand side is I, right hand side is none. So not much difference. Both did a good job. And execution results, let's see. Both sides 1,229 which is the same as the official example in AutoGen website. Looks good. And you can also see a summarization of the chat results. Then we go to another example, is a group chat in AutoGen, a different example. In this example, actually, the group of the agents will perform two actions primarily. First, to retrieve the documentation or the context, then analyze the document. So in order to retrieve this document, it actually uses a coder to generate the code to get the information. Okay, so let's see the results. You see the prompt is find a latest paper about GPT-4 on the ArcCV and find its potential application in software. Okay, so we see left-hand side is 3B model, right-hand side is 1B model. So let's first take a look at the 3B model. Okay, it goes to generate the code, okay, and describe you how to analyze the different application in software and so on. And also the coder tries to code and you can see here there are some generation of the code and so on. Then execute the code, you get error and so on. Then it goes on and on, but it seems that there is no correct code generated, because you can see the code output, no paper found on GPT-4. So there is a potential issue about the code, and eventually I exceeded the Grok token limitation, so I just stop here. So the different agentic workflow was executed with success, I mean from the flow point of view, but the result is not so good because we cannot get the paper and the information. So let's take a look at the 1B model on the right hand side. So the same workflow, it first of all lets you know that it's a large language model, do not have the ability to process a dynamic links. Okay, then they generate some code, but that code of course cannot be run because it's too simple, and you can see there are some errors. And yeah, eventually it also gets to improve the code, but when we execute the code we got an error. Okay, so it's like this, and eventually it said it still comments on the error of the code, but eventually we cannot get satisfactory results. You can see the summary of this code of the agentic flow, and that's it. So both models failed at this task to make this agentic workflow work. Now let's take a look at the official example. So in AutoGen website, the same agentic workflow goes on, and because it was using, I think, a GPT-4 model. Let's check. Yeah, you see it got the GPT-4 models, and eventually the code was generated and executed to get the information, summary of the paper, and eventually they gave the opinion, okay, and terminate the chat. So again, these two models are smaller models than GPT-4, and of course in the agentic workflow they do not work very well with AutoGen for the cases I just mentioned. Of course, if you implement additional tech, additional tricks with the design of the workflow, you will get better results. So the first agentic example is a very simple one, and we get a result. The second one, when we talk about retrieving information, both models find some difficulty to execute and get eventual correct results. Now let's go back to the local machine. Let's test the agentic workflow with Llama using Llama 3.2, 1B model and the 3B models. So as introduced, both models could be pulled from the Llama, and I just use a Crew AI framework to design the workflow. So basically the workflow is very simple. I just have one student agent, the other is a teacher agent. Okay, so student ask teacher questions on 3 levels. As you can see below, here we have 3 level questions. Of course, you do not need to test this much of question numbers. So eventually I change it to 3, 6, and 9 in the 3B model version. Okay, just to simplify the agentic workflow and a limited response length. And as you can see in Crew AI, we need to both define the agents and define the different tasks. Okay, then you are forming this crew group using relevant functions. And let's see how it works out. Okay, so basically using 1B model, we immediately get this error. So in Crew AI, when the different agent calls another agent, it's very important about the name, and it is case sensitive. Sometimes the agentic workflow can figure out which is the eventual correct name and call the correct agent, but this requires you to be very careful about your coding part. You need to implement some flexibility, or you use a better model to achieve better results. Like this one, we use Llama 3.2 1B model in Llama, and we only get errors. Okay, so it cannot find the coworker, and we do not get any result at all. So I stopped the workflow. However, for the 3B model, let's see. Okay, it actually starts to generate the questions from the student to ask a teacher. I want to understand the basics of statistics and its relevance in everyday life. Okay, then here, coworker not found. Okay, so it goes back to thinking by itself, the student, and let's see here. We get the answer from the teacher. Statistics is the study of collection, blah blah blah. Okay, we'll get the answer, and then back to the student. I now understand the basics of this question, and additional question generated. Explain the main types of statistical measures. The teacher got answers, then replied. So basically, if you see a different color, this is the reply after the thought chain, I say, and you can see we get some results. But later, we see error utilizing tools, two validation errors of asking questions to coworker schema, and we can see some value is missing, and we lost in the chat flow. But when you retry this same workflow with the same model, like this version, you are going to see quite different results. So basically like this one. Okay, we ask questions, get a response, okay, and we can go more rounds. As you can see here, we go to deeper questions, like what type of questions should I ask when trying to understand the statistics, okay, and there are some questions generated, right? And then we can see this conversation can go on, but at a certain step we can see the action input about the question, observation, thoughts, the action input observation that keeps is like the thinking process of one agent got stuck. Okay, and it still tries to ask the other agent, ask a teacher these questions, but it seems that it does not get passed to the teacher agent. And as you can see here, I should also ask contextual questions to ensure I understand the product concept and so on. So there is no interaction with the other agents. Okay, it's a self-reflection process. And now we can also see some code generated, but we do not get very meaningful discussions between the two. Eventually, we got an error, and I stopped this chat work. So basically, both models can handle a certain number or rounds of conversations in Crew AI, and of course 3B model is better than 1B model because it's bigger and it can handle more complex situations. So we have done the journey of testing some use cases with the new Llama 3.2 1B and 3B models, but before we go to the conclusions, please be careful about the interpretation of the results, because whenever you utilize different models, you need to check the specification. For example, the LLM Studio community version may be different from the Llama version and may be different from the Grok version. Okay, because the different quantization level, you have a different size of the model, and in a very strict sense, there are different models. Okay, they may be based on the same framework, the same original model, base model of Meta, but they may be slightly different. Okay, so whenever you interpret the results, please make sure that you understand the backstory of different models. Here, I give you a simplified peer comparison review. So let's go one by one. We have done a Q&A on concepts and on specific questions. So both models have shown some results, and the 1B model seems to be more practical, give you some coding suggestion, and the 3B model in general give a more comprehensive, better answer. On specific coding task, of course, 3B model performs better than 1B model, and on the agentic workflow, both models from the Grok website work very well on the simple math coding task, the agentic group chat. And about the information retrieval, both failed. And on local tests with Llama and Crew AI, the teacher-student chats have more meaningful conversations in 3B model than 1B model. And if you keep testing, for example, with the Crew AI to start a new conversation between the student and the teacher, you are going to see different results. So the randomness of the response and the interactions is very interesting for you to explore also in the future. Before we close this episode, this video, let's take a look at the official website of Llama 3.2 published by Meta. I'm just going to mention two things. First of all, in the front page, it said lightweight and multimodal Llama models. Okay, lightweight means that 1B and 3B models are smaller in size, so it can adapt to different devices like our mobile phone, like our laptop, and so on. Regarding multimodal models, of course, you can try in the future and see how these models work. So today we just tested the 1B and 3B models. They are on device, they are small, they are faster, and we can see there are some pros and cons about shrinking the model size. Especially you can see on different tasks the performance can vary. Then you can also check on our official website about the different benchmark comparison. For example, this one is the vision instruction tuned benchmark. Okay, it's about multi-modality models, and about the lightweight instruction tuned benchmark about our Llama 3.2 1B and 3B models. We can see that it cannot surpass or go over some benchmarks of the previous models on all benchmarks. So let me say this. In my opinion, different models may be more suitable for different use cases, but you need to test to understand, and on your specific use case, you need to design a better structure to utilize these models. If you only rely on one model to perform all tasks, for example, like these on-device smaller models, it may not get good results. But I'm going to check in the future if there are some more creative design. For example, in the on-device situation, it can perform very specifically on a single task with a very high performance score. I'm going to share with you. And I think there are potentials about the smaller models, but the generalization or the ability to handle a more broader range of tasks is not as good as the big models. Anyway, let's keep on exploring and see what the large language model community is going to bring us in the next time. So I wish you like this video and wish you have a good day. If you have any question, feel free to leave a comment. If you like my video, please subscribe to my channel, and see you next time. Bye bye. Hello everyone, welcome back to my channel. In this video, I'm going to show you how to evaluate the podcast generated by Google Notebook. I'm going to do the following steps. First of all, I get to the text information I need. Is this economic bulletin issued by European Central Bank? And I insert into the ML notebook, insert in the source part, and let the notebook generate the conversation. So this would be a podcast style voice recording. Then I'm going to get the transcript like you see on the right hand side. Then I put it ChatGPT to evaluate the whole recording. And eventually we are going to see the comparison between the two text blocks. So first of all, if you want to do such kind of test, you need to first find the text information you want to analyze. This one, I choose this page because from the URL, we have the text information of the whole report ready manipulated. And if you insert in ML notebook, whenever you add a resource, see here, we can copy the link directly to load it. After loading it, we can see notebook guide, and we have audio overview and a summary. So today my interest is to analyze this audio generated. So if I click load, it will start generate. I'm going to show you the result right hand side. So after generate this audio file, I'm download. Then I go to my Microsoft Word interface, and I can use the transcribe function to load this audio file. And as you can see, after transcription, you can see all the text information. Of course, if you have other tools you can use, see how it goes. So now I have the text block originally ML Go, and now we are going to evaluate this podcast quality with the original text as shown here. So first of all, I save transcript audio file and ask the model to wait. So basically you can see here I text information and ready to use. Then I copy text facial website. I ask the model to find similarity, find difference, highlight any statistical number in a table. So this is the whole text information. Of course, it's much longer than podcast text information. Now here we see this is a detailed comparison between the two texts. Text 1 is the transcript, text 2 is the economic summary. You can see that the first block is similarities, second differences, the third is highlighted statistical information in a comparison table. Let's just say in the first block of the similarities, we can see the descriptions are quite close to each other. Like you can see here, with the transcript discusses the growth of 0.3% in Q1 and Q2 2024 driven by service. In text 2, we mentioned slow growth in Q2 compared to Q1, but also 0.3 growth. So there is not very significant difference. And if we check the difference part, you see the interest rate changes in the transcript focuses on potential for future rate cuts. And in text 2, no changes in interest rate, keeping them at restrictive levels. So we can see here we either witness the hallucination of the model or the summarization capability is not ideal. Then we check the statistical part. My original intent was not to ask it to compare the economic data here. I want to see the statistical comparison between the two text blocks. Anyway, this table it presents here. I see some differences. I think it is also good, but I'm going to improve the analysis in the later part. So I was asking how is the general sentiment of the two dogs differing from each other. So I'm asking the model to do sentiment analysis. As you can see here, it starts to analyze text block of the transcript and of the original doc. For example, like this one, you see there's tone, sentiment, perspective, in 3 parts. And there is the overall summarization of the difference of the sentiment. Like the transcript feels more accessible and mildly optimistic, and the official document seems more serious, cautious, and slightly concerned. And now we see how would it rate the podcast on each paragraph. So engagement level, fact presentation level, information cross-check level, professionalism as a podcaster, and professionalism as an economist. So here we see the paragraph by paragraph evaluation, and starting from the first one, we see all the metrics evaluated by GPT-4o model. Let's see. Until the end, it does a job as a data analyst, so I do not do any additional coding. So there was a bar chart here, but now since I reload my conversation history, it does not show again. Now let's see. I also asked it to offer the error bar chart. It looks not so clear. However, we have the rating table in a CSV file, so we can download and manipulate further. So I just describe further my request, ask you to improve. Okay, so this one looks much better. So we can see the general engagement level is ranging from which level to another level. And now I can see, in generally speaking, we can see the fact presentation level and professionalism as a podcaster are in general higher than the other measurements. Okay, now I further improve the visualization. If we put it horizontally, we can see the different metrics compared with each other. Okay, so we see the professionalism as a podcaster has reached a higher score in general, so which means that it is more skewed to the higher level, which is what I expected. And in the other metrics, you can see the scores range is skewed to a lower range, and the span is larger. Okay, like the professionalism as an economist. So basically, some of the comments or claims are not as professional as an economist, but sometimes it can also make an accurate claim. Yeah. So with the visual, I think it's very easy to judge models. So now I wanted to get a histogram and further smooth it, and here we see the final result of a KDE plot. So as I said, you can see the different distribution of the scores and how they are skewed, and which is the density of the specific score. For example, like this pink line, I think is the professionalism as a podcaster, as I said before. And we see most of the score, the average score is around 8 points, which is around 8 points, which is higher than the other categories, and is skewed to the positive level. Okay, so with these visuals, we now can say that using different models to evaluate the outputs of another model is a very good way to give us the first impression of how the models perform. However, if you could get multiple models to work on the same evaluation, it would be better. For example, if you have some free models in localhost, for example, you don't have GPT-4o, you can generate the matrix or the text evaluation information, then summarize it to a data table, then utilize Python in local environment to do the analytics. Utilizing ChatGPT or other online tool is going just to speed up your process of analysis, but I always recommend you to be cautious to interpret all the results. I wish you like this video, and just to summarize, we have a way to evaluate the outputs, especially the audio output of another model with ChatGPT. If you like my video, please give it a like. If you like my channel, please subscribe, and see you next time. Bye bye. Are you tired of analyzing docs for work? Do you want to study more efficiently? Are you tired of taking notes? You just need some summaries, insights, and get them fast. This video is just what you need. Get hands on AI tools and boost your productivity. Here are 3 tools to get personal knowledge assistance. Let's get on with it. So the first question is, what are these tools we are going to discover? Let's get into the first one. It's called the Notebook LLM. It is an AI research assistant powered by Google's most capable model, Gemini 1.4, or we can say it is a notebook-style document chatbot. It can serve as a research assistant, information. It can transform information to insight. It can also get inline citations of the document analyzed, and you can access the tool from the URL I listed here. Then let's take a look at OpenWeb UI. It is an open source tool which allows you to run various large language models in local environment. It can also link with Llama and other OpenAI compatible APIs. Or we can call it a web UI style chatbot. It can be deployed in local environment free of charge. It is open source and you can access from this URL. Now let's take a look at ChatGPT. Of course, now ChatGPT is the most famous chatbot tool to the public, and it has the industry leading models to allow you to complete different tasks. It is a market leader now. They host some leading models in the platform. You can access via this URL, and they also have an application so you can access. Another question is, why do we need these tools? Sometimes we find the document is too long and we don't have time to thoroughly read every word, or we just want to summarize a long information. Sometimes we also want a retrieval tool to get the key information I want, or to ask a question about this document. I also need a personal writer to get a nice structured summary or some of the quotes that I can use directly. And I also want a tool to do the experimentation, to understand the large language model and to understand how different structure of large language model could work and benefit my use case. Then let's see how. How do we use these tools in practice? I'm going to take one example that I explore the HuggingFace space and dig deeper into the document behind. We're going to first of all find this HuggingFace space to play with, and then I have some question. I want to know more about it. I start to explore. Eventually, with all these tools, I can understand better about the background, about the theory, about the research of this demo of tools in HuggingFace. As you can see here, I go to HuggingFace Spaces page. I find the first tool. It's called Office 1.6 Llama 2 9B. It is actually a chatbot interface which allows you to input an image and also text message as a combined prompt and get results. But from the interface here, I cannot understand the backstory, the research, and the paper behind it. So first of all, I go to the GitHub to see GitHub page, the code, and the descriptions of this project. I find their paper link, so I go inside and check this paper. To understand this paper, no matter which is your level of understanding of large language model, you might prefer to read all the documents, read every words, and get your idea about what they are doing, a theory, and if it could be useful for you. You can also use other tools to summarize. So personally, I always prefer to summarize the document, get some insight, then go back to read the documents. In here, you can download the paper as PDF and further analyze it. This is a paper, download it as PDF. Later you are going to see I'm going to use different tools to analyze this paper. There are different ways to upload this document. You can upload the PDF to the tool, like to ChatGPT or OpenWebUI, or you can just copy the link of this PDF, like to NotebookLM. For detail of how to prepare these tools, please check my other videos. Now let's take a look at the results of NotebookLM. So after importing the URL of this document, it first gets insight. As you click the notebook guide, you're going to see the insight. But here I'm going to show you some of the Q&A process because I want to get some information from it. So I ask several questions. After loading the document, I ask, what does this paper talk about? Use simple language. It actually summarizes this document and make a very detailed citations to every part. So if you click the number 1 citation, it will show you the corresponding part on the left-hand side. It is very thorough and very detailed. And you can see it actually captures the details of this document and show you its summarizations. As you can see, the left-hand side is the citation part of this paper. Right-hand side is the Q&A interface. Now I'm showing you the whole answer from the NotebookLM. If you are interested, please read through these texts. But but as my understanding, they are very thorough and include all the necessary details for me to understand this paper. And you can see here the breakdown of the content is very structured. First of all, you have an overview, then it tells you how this project works. And until here, we are still looking at the answer to the first question. It has also shown you how does this project or this model perform, what are the limitations, and so on. Then I ask it to show the steps of the works done. It actually shows all the necessary steps, which I think is very close to the original paper contents and already covered most of the points that I'm interested in. Then I ask another question: which background knowledge should I have to understand this paper? It gave me a list of the things I should know. Very importantly, it mentioned the multimodal large language model first, because that is most close to the subject discussed in this paper. Then further about the natural language processing, it does not jump to large language model, but it goes to the natural language processing topic. You can also see the other details as listed here. Then ask another question: what does the paper talk about? Use simple language. The reason I ask the question again is to let you understand. Whenever you talk to a large language model, you ask the same question for as many times as you like, the output will be different. So the key is that if your question is well answered and well evidenced by the background story, by the related documents, I think you already get to understand the information or the documents. Let's take a look at OpenWeb UI. So with this tool, I actually tested 3 different models. I'm using Grok API because at this moment, for developer, it is free, and I can change the models I use. I use the Llama 370B model to get the first answer, then Llama 3.2 90B text preview model, then Llama 3.2 11B text preview model. So I can compare the different results of the Q&A on this paper. And here I just show you the result from the Llama 3.2 90B text preview model. As you can see, sometimes when I utilize this tool to ask a question to a specific model, sometimes it cannot capture my question at the first shot. This could be a problem. With the open source tool, how this tool is parsing the PDF document to get the information and send it to a large language model. As you can see here, it gives me some of the ideas of what this document is about, but as you can see here, it is less focused on the project itself. Some of the descriptions are very general. These descriptions are in general very simplified and in a more general sense. As you can see, I first asked to analyze the doc. It gives a general response. Then I ask how it is done. It actually gives some ideas, but it is not as precise, as accurate as Notebook LLM. And you can see which background knowledge should I have to understand this paper. It gives me some list of topics I should learn first, and it goes from NLP to the different parts. But you see, in the Notebook LLM, it started from the most close one, and most specific one is multimodal large language model. So the approach is different. And I asked again about what this paper talks about. Of course, it gives another answer. You can see this is just to tell you again, no matter it's closed or open source models, always be careful about asking the same question several times. I also did a video before about the different results from large language model and how you can visualize the difference of these results. Please feel free to check my previous videos. Then let's go to ChatGPT. As you see here, I first attach this document and with my prompt. What does this paper talk about? Use simple language. It captures the key with the model name, obvious, and the model type it is using. Also describe the key challenges the test has done by the author and give a brief summarization. It looks generally good. Then I asked about the steps of the works done. It actually gives a more detailed overview of the steps: problem identification, introduction of the model, key innovation. This is a little bit different from the notebook ML. I think the quality of this part about the steps work done is almost the same. Both of the ChatGPT and notebook LLM showed the detailed steps and the general structure of the research. Then asked what background knowledge should I have to understand this paper. It actually goes first to large language model, then go to the multimodal learning. It is different from the notebook LLM. Personally, I still prefer notebook LLM because it points out the most related topic, then go to a higher level and go to the other details. The quality of the ChatGPT results is also higher than the open web UI results I showed you before. Then I asked what does the paper talk about? Use simple language again. As you can see, for sure, the answer will be different from the first time I asked the same question. Always bear in mind, large language model still has limitations. In the end, it is good to ask another model to evaluate all the results. So I asked Claude. I use the free access model, so I just upload all the chat records and ask it to evaluate. It actually sets up several dimensions to understand the Q&A qualities of different models. We have consistency, clarity, completeness, accuracy, and simplicity. As you can see here, we have highest average score of notebook LLM. As you can see here, it's 4.8 points. And for the open web UI models, we have in general lower average scores. But as you can see, the ChatGPT results is obviously, or as I understand, better than the Llama model I used. But Claude ChatGPT a lower score. So one point we can use the model to evaluate all the results for us to better understand which tool is better for this task. We also need to have our understanding to better understand results. If we only rely on Claude, it may have some problem. At least from my personal point of view, I think GPT is now doing a better job than Llama 3.2 90B model. But again, this test still is not 100% comprehensive because in Open Web UI, how the tool is parsing the PDF information, how the information is sent to the different models, we still need to further evaluate. But at this moment, I prefer notebook LLM tool to do the analysis for me. Then in the end, which model should I choose to my specific use case? First of all, we need to consider expense. Which one is free? Which one I need to pay subscription fee? Then I should focus on my use case. As I said, I need to understand what is the objective I want to, what is the task I want to accomplish? What is the result I want to get? And we need to understand the answer, the usefulness of the answer. Is it too general, too specific, deviate from my objective? We need to evaluate. So ChatGPT, it has the closed source models. To use the best models, we need to pay, and it has application and web access. For notebook LLM, we have closed source model. It is free for now, and we can access through the web. For the open web UI, we have the open source models and also some APIs like Grok we can use, and it's free. We can access it using local machine. So in this video, I introduce you different tools to do the document information analysis. I wish they could be useful for you for your future exploration of large language model, of the AI tools, and please do some tests of different tools, understand your use case, and best solution for you. If you like this, if you like my video, please give it a like, to share my video. If you want to see more content like this, feel free to subscribe. If you have any suggestions, feel free to leave a comment. Thank you, and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today I'm going to show you one of the tests I have done recently. It's about utilizing different large language model to provide alternative endings for the movies, and we analyze the movie endings and see the dispersions using different visualizations. And we are going to also do some basic sentiment analysis on these endings. So basically, I chose the Lord of the Rings trilogy, which was a very famous movie saga, and I used the transcript as a basis for our analysis and interact with local Llama tool and also the different large language models already downloaded. In addition, I also used the embedding model to transfer the textual results to embeddings for further analysis. So as you can see here, I have a brief summary of each step of the analysis. In general, we load the transcript, generate the endings, then generate the embeddings, and first of all, we try the dimension reduction and visualization on all data together. And we separate it into different movies and also do additional analysis as you see here. So let's go to the main part. First of all, you see here is the load transcript, generate endings, embedding transformations. In here, basically, you need to prepare Llama and download the models that you're going to use. For example, here, these are the large language models I'm going to use, and you should be aware of how to use Llama module in local environment. So preparing all the interfaces with Llama and also the transcript, then we are ready to go. And here we use a function to generate and save results. We have different models and we have different movies already defined. And in here, I'm going to do 10 iterations to actually call each model 10 times to generate a different ending based on the transcript I gave and for the movie I defined. So I'm going to see a different endings produced by large language model and further analyze it. Then here, after generate all the endings, I'm going to generate the embeddings based on the text message or the endings that are given by the large language model. I'm going to further analyze these embedding results. And in here, I just call the functions on different models and work on different movies and generate and save results. Eventually, I'm going to have 3 models working on 3 movies for 10 times. And here, I just save the results to a CSV file so that in case my program just stopped here for the next analysis, I can read the CSV file very quickly without rerunning all the code. And here, I'm going to see it in 2D dimensions display after PCA transformation. As you can see, there is additional work I put in the code because I want to see the progress of the running of the code. As you can see, generate the different endings cost me about 40 minutes, and to embed all the different endings took about 3 minutes. So this is optional. I just want to see where the work was. And for the 2D display, you can see that we might need to further cluster the data points to get an idea of the dispersion. And of course, we need to separate it into different movies because here we don't separate them to different movies. We just see a general situation. Then I also add this part for 3D PCA visualization. As you can see here, if we just increase the dimensions, the dispersion of the results would spread to a larger range. Here we just get a general idea of all the results, but of course we are going to separate them into different movies. So I also added this code block to save the embeddings to the existing CSV. So as you can see here, the first run I get this Lord of the Rings endings CSV file. So when I add the embeddings, I have this file, the previous file with embedding values here. So now I have a complete set. Of course, if you put this part in the beginning, I think it's also okay. But here I just want one CSV file without embedding another with. It's optional. And here I choose the cluster number, which is the optimal cluster number for the clustering in the later step. And as you can see here, with the elbow row, we just choose the points where the marginal decrease of the inertia value would be the lowest. So I choose number 3 for the clustering number. But of course, if you see the second and third graph, maybe 3 is not a definitive number. For example, like the last one, we can still further see the marginal drop of the inertia actually do not have a significant lowering trend like the first one. However, you can also try to use different cluster numbers. I just want to keep the best number for all the situations to simplify our analysis later. Now we do the PCA analysis on different results in different movie generated by different models. As you can see here, if we reduce it to 2 dimensions or 3 dimensions, we can see the dispersions are quite different. But one notable point is that in either the 2-dimension or 3-dimension cases, we can see some points are very far away from the larger crowd. I mean, like the first one, you can see the right-hand side, we have both the two groups of the results are relatively more close in component 1, but there are 3 dots very distant from them. But only from here, I only see this distinction of in a PCA sense some outliers in the graphical sense, and also I can see in the right hand side different clustering group actually overlap in the upper right hand side. So we might need to explore further and see why there exists such case where the clustering are different, but from a PCA point of view they are very close. Then, to better visualize the result, I chose to label these points. So in this way, I can see which are the data points referred to different models. So, like here, we can see in the upper left first chart, we can see the clustering are quite distinct from each other, and the outlier, the 3 purple dots, are all related to Llama 3.2 1B models. For the other models, most of the data points are on the right-hand side. So it could give us a sense that in the 2-dimensional space, Llama 3.2 1B model could generate some results which is very distinct from the other models. And from itself, we can see like the upper right side here, we see there is one data point referring to Llama 3.2 1B model. Inside of the same model, the generated contents could be very distinct from each other. And we can also check the other results and in 3 dimensions. Now let's go to the next part. I also use this code block to print the table. As you can see here, I want to see for each movie which model I used and which is the result belonging to which cluster. Okay, so by doing this, I'm preparing for the next step. As you can see here, there is a summary table here. We have 3 clusters, 0, 1, 2, and for 3 different models, we have different counts. So in a brief way, we can now understand for each model how are the clusters how is the clustering operation separate the data. Like for Llama 3.2 1B model, we have 9 results for this movie Return of the King on cluster 0, 1 results in clustering 1. So it could mean that most of the data points are quite close to each other, and we can see in other models in the last model 3.23b model, they are quite separated to two groups, not concentrated in just one group. And for the 3.18b model, the results are dispersed in a wider range. For other movies, the table and the statistics you can check in other parts of the output. Now let's go to the other part. We print some of the example. So basically this part, we just print some of the pairs of the results which may show different characteristics. So we might have the same model for different clusters, or we may have the same cluster with different models. So after getting the results, of course this is a very long text message, I just further analyze it using GPT to get a summary and see how different they are from each other. As you can see here, so we first check the first movie, Fellowship of the Ring. We have the situation where same model but different cluster. We have Llama 3.18b model. We have cluster 1, cluster 2. So based on the summary of the results, you can see the first one actually gives a different ending for the movie, and there are some deviations from the original ending. But for the cluster 2, where is the second ending style, we see that it does not offer only one ending. There are multiple endings suggested by the model. So this is the same model generate two different endings. Just by the display of the number of the endings, we can intuitively understand these two endings are quite different. Or we can say the two endings generated by the large language model are different. Then we see here there is the same cluster but different models. We can see both of the two endings are clustered in cluster number 1. And the first ending is a similar plot, blah blah blah, as there are some deviations from the original story. And the second one, they do not change very much from the first result you see above. So from here we can see they are quite similar. But again, to understand or to analyze a large chunk of text, if you want, you can also go to Analyze by yourself, reading through all the details of the text message. Here we only show a brief summary. So our analytical results is not based on the summary, it's based on the different endings generated by large language model. Here is another distilled result for you to quickly understand and view the analytical process. And you can also see the other movies where you can see still the same model to cluster situation or same cluster to model situation. So until this point, we can still see that the models can generate quite different results, and two different models could generate very similar results. In the end, we also add additional sentiment analysis. So we are using the text blob, the sentiment analysis tool, to analyze the different endings. Then we put it into the visualization and also the tabular information. In the tabs here, the table, you can see that which is the sequence of this ending, which is the model, which is the movie, and the prompt number, generated ending, polarity, and the subjectivity. These two figures are generated by the sentiment analysis package, and eventually we get this graph. We can say polarity is a negative sentiment or positive. So in general, we can see that a large part of the results are prone to be the positive range. Relatively smaller part are to the negative range. And in the negative range, we can see subjectivity level varies a lot. And of course, the most subjective points is in the negative sentiment range. And based on this graph, we can see that for different movie, for example, like the Fellowship of the Ring, the round dots, how they disperse in the polarity range, which are positive, which are more negative, and also the subjectivity level we can see from this graph. Of course, we can further separate this graph to give a better visual to understand if some of the model are more prone to give negative results or some models are more prone to give positive results. But for this test, I'm going to stop here because to do a more segmented test, I prefer to have more data points because now my data points are quite limited. So I think I'm going to stop here and to get a general sense that, first of all, large language models may give different story ending to alternative in a different range. So there is a creativity part of the different models, and for different models the dispersion range are quite different. Some models may be very creative, each prompt give very distinct results. Some models may give quite close results. And for the further analysis of this kind of test, I think we may also expand the model range and also group the models, some of the small models and the big models, to see the difference. And also we can try to use other text information, for example, like a novel, not a movie transcript, which may have more contextual information inside, because like a transcript, most of the text information are for the movie and are quite simplified, not like a novel with a lot of contextual information. And furthermore, we can also try different embedding models, different sentiment analysis models, and we can also try the analysis of the sentiments in each segment of the movie or each segment of the predicted alternative results. So there are many ways that we can expand this test. But here I'm going to stop here. I wish this could be inspirational to you and to help you to explore the different test projects. I wish you like this video. If you like it, please feel free to share it or like it. If you like my channel, please subscribe, and see you next time. Bye bye. Hello everyone, welcome back to my channel again. Today I'm going to do a tutorial on how to use ChatGPT. As most of you already know, ChatGPT has been a dominating AI chatbot around the world. They have very capable models to help us to accomplish daily tasks, either for study, for life, for research, and so on. Although they have some fundamental defects like a hallucination, imperfection of output, and so on, I still think it's very useful for us to understand how to use it to boost our productivity. Now we take a look at the ChatGPT 4.0 model first. As we progress, I'm going to introduce you to other models, but this one is the most direct and it is now the default model that you are going to engage after logging to ChatGPT. Case number 1, simple question and answering. So let's ask who is Tom Hanks, and the chatbot will give us the reply on who he is. Of course, this is based on the ChatGPT training data. And if you stop here, you have a great chance that some of the information is not accurate. So if you want to further increase the reliability of the response of the Q&A, you can go ask cross-check on the internet. This is one way to make sure that the response will have a more robust proof. So as you can see here, ChatGPT already did additional search on Bing, Wikipedia, and other websites, and eventually give you this response. And you can see also here are citations where you can go directly to the source of the information. It will make the results more reliable. Case number 2, if we go on with this question, let's see, can you summarize some statistics about Tom Hanks in his career, cite sources. And we can see now we are going into another step to understand the statistics about this person's career, and also we can see some numbers here. So this could be a quick dive into the data analytics about a specific topic. As you can see, if you ask questions with additional requirements to cross-check or to show the sources, to cite sources, you are going to get more robust response. Case number 3, let's see if we can transfer this textual information into statistical table. Okay, let's try it. Please provide statistical table for the stats you gathered. And you can see now ChatGPT is running the code in its own environment to analyze the relevant information and put inside. Usually, if you already have some chat results, it will transfer those statistical information to a data table in his environment. And as you can see here, you have a tabular data display, and you can also enlarge it, expand, and you can check the whole table. Of course, some of the values, for example, this is dollar value, and then you have the count value. Some of them are not in the same standard, but you can always improve and ask additional to perfect these statistical information. Now, let's go to the next case. Number 4, data analytics. We do not just gather the data table, we actually go deeper to the analytical aspect. Now, let's expand the data analytics range. Let's say, please compare 5 more actors like Tom Hanks. Gather the similar stats, separate in dollar value data and count data, show comparison in graph. As you can see now, ChatGPT has gathered several names like Leonardo DiCaprio, Denzel Washington, Brad Pitt, Robert Downey Jr., Johnny Depp. Okay, so it now gathered the relevant information from the reliable source. This is because I already asked it several times to cite the sources, so now in the new response I do not need to specify it. But if you see that it is not citing sources, you can always ask it to do so. As you can see now, we have the information gathered. Now it is starting to compiling the information gathered. As I specified before, now we need to set the dollar value and also count value in separate table. And we can see here, it does a quick job. Show first of all the total global box office gross income of the famous actors. As we can see, the different actors are compared in this bar chart. Looks good. And we can see here, we have the comparison of the award-winning amount of actor in different awards. So this bar chart is also organized well. You can see here is also a summary that is said that I have created 2 sets of visual comparison, global box office gross, and also award comparison. Of course, I always recommend you to check the data gathered because sometimes it may not be 100% accurate. This is an issue of models that we're using now. Now let's go to next case. Case number 5, advanced data analytics. So we have already gathered some of the statistical data, And we want to see more example because I want to see more actors, for example. And we want to see a classification to see how can we group different actors. Okay, let's try. Expand actor range to 3. Gather relevant data and categorize them according to the data you gathered. Use proper machine learning model. Okay, as you see now, if ChatGPT is giving you 2 responses, because now the response of ChatGPT sometimes cannot reach the organ. So now there is a reinforcement learning step. Ask the user, like you and me, to choose between the response, see which one is better. So it will act as another data source for them to enhance the performance of the model. As you can see, there is a response number 1. It goes to a deeper thinking process, and response 2 already gets the result, as we can see here. And it stops at the machine learning model choosing, suggested the k-means clustering or random forest classification. As you can see in the left-hand side, it actually goes to, first of all, the list of actors, gather the data, and also describe the data analytics approach, the process for the preparation, and the selection, and evaluation, visualization, and so on. So the response number 1 goes into a chain sort process. So the response looks more robust than the number 2 response. Okay, and as you can see here, only on the second response, already get the 10 actors information, right? I want to show you the example, and it will go on. Okay, as is the first to see, I can't provide you data analytics and the graphs without our data. It only shows you and not do further about the word. So I'll choose a second response. I will say good. You can see now it starts to write out to analyze the data. And you can see here, only problem is that it only gathered the 10 actors data, reading the data frame and normalize data. This looks good. It's very good approach, data analytics, and apply the k-means clustering. And you can see it uses the statistics, box office income, academic words, total words, and words count. And we can see we have this cluster chart shows a different cluster of the actors. As you can see, it's actually separated into 3 clusters. Cluster 0 with moderate box office performance and combination of awards, and these are actors included. Then cluster 1 with high box office growth, the relative fewer work looks accurate, and also high word count and substantial box office figures. Now you can also choose to download the chart to your local environment or go on with the chart. Since the response does not match our expectation yet, let's go on to ask it. Please make sure you include 30 actors. Okay, because now we have 10. So it starts to describe you first what it is going to do, gather data, process, and we run k-means clustering. And here we see my actors are joining in the analytics process. Let's do a brief count here. We have 5 columns here. 5, 1, 2, 3, 4, 5, 6. Yeah, we have 30 actors. We also have a table, but as you can see, some of the data is not available. So when you do the analytics, you will have error, and it's to resolve this issue to correct this error. So now suggest to replace the missing value with mean. Okay, let's see what I have done here. It actually choose the mean value to the not available data. Makes sense. Also, you can also skip to choose 0 to substitute the NA value. Now let's see. Okay, the data looks okay now, and we go the different results. We have the class chart, as you can see here. The actors are clustered into 3 categories, and we also have the detailed table here. It looks good. Of course, you can also download it to do further analysis. Okay, so in this case, we can our data. We apply a machine learning algorithm to categorize the data. Case number 6. Now let's summarize the information we gathered and analyzed of. Now let's say write a summary report on the analytical results as a hypothetical data analyst called Tom. As you can see, it now drops the summary report of the data analytics we have just done. It describes the approach, detailed steps, and the results and observations. And it also gives you the conclusion here and the recommendation. I always see these parts of recommendations very valuable to give us insight to do further analysis and to see how the large language model has improved over time. Now let's take a look at case number 7. In case number 7, I'm going to ask the model to draft an email to send the information to the boss and to schedule an appointment to discuss it. So let's see. Please draft an email to send above results to the analytical team boss called Tim and schedule an appointment to discuss the analysis tomorrow 2 p.m. Now it starts to draft the email. I really like the function to draft the email because it saves your time. You just need to create, to modify the email, you can send it. You see here, for the appointment, actually add this text message to send an email, and in general looks good. Now let's go to case number 8. We ask for additional task. So I will ask it, please update my Google Calendar for the appointment mentioned. So this will go beyond its capability because it does not have the link with my Google Calendar. The model will instruct me how to add the appointments to my Google Calendar. And you could have other options. There are many tools that can choose. For example, the GPS created by others to perform such task. But you need to consider, the more you involve the third party, the more you're exposing your personal information to the third party. So there is the tricky balance here. Case number 9. Alternatives to the uncompleted tasks. For example, as you can see here, we cannot ask GPT to do the job for us, but we could have alternative. For example, you have the calendar file attached to an email, the company could receive it and also open it to include the appointment in the okay. So I will ask this, create a calendar attachment file for me, so I send this email. As we can see here, model starts to write code, although you can see that it isn't very fast, and eventually is the file in environment and will provide for us to download. As you can see here, the model does not successfully provide a CS file for us. This is one of the cases where we need to obstacle in this model. However, we can also copy-paste the code to our environment to run such code legibly or Google Calendar. In other cases, for example, if you want to ask ChatGPT to generate a notebook file for you to run local Python experiments or in Colab, sometimes it can generate, sometimes it cannot. Or you need to try and see if the model can provide the answer you want. This is part of the instability of such kind of model, and you are going to see the cases as long as you use more and more of such models. Now let's go to case number 10, coding. So in this case, I'm going to use two models of ChatGPT, is ChatGPT 4o and Canvas. So I'm going to prompt to get the code and then run in my Colab environment. So the code would be provide me with the Python code to run in Colab, getting a APL price trend and conduct technical analysis to judge the buy or sell opportunity. Going to prompt both 4o model and also the 4o Canvas model. As you see here, the display are quite different from each other. On the left hand side, you see is still the chat mode, and you see the results, you see the text block, and also the code block. On the right hand side, it goes to the display of the code only. If you want to change it, you are going to see the update of the code on the right hand side. But on the left hand side, if you ask for change, it will generate a new response. So let's try first of all the left hand side code. Let's see it works. Now let's copy it here and run it. Okay, so there is an error about code. I just copy and paste this error here and see if it can bug. Okay, now let's copy it to code environment and run it. As you can see here, we have some results. For example, the moving average, SI, MACD, different analysis results. However, in the end, we still have an error here. Okay, so let's debug. I suggest you check out of the code. We're going to list the code and check it. Okay, still one there left. So I think this is the error of importing the ChatGPT. Let's see what will modify the code. Yeah, you see. Here, add this line. I think package will go to insert. Let's just copy the rest of the code and run the code. Do here, do code block, run it. Oh, see, we have some results, right? We have some results about the stock price, analytical signals, the basic timing. But try the signal, it won't give us answer, right? So in this case, not debugging the error, we do not have any bug to copy and paste, but we can describe the E here, the signals or the name, and see if it can understand and solve the issue. So this looks okay. We need to check values, cross-check logic, extend the data range, and let's see. Well, let's share the data. Okay, and let's provide this data back to ChatGPT. Okay, so it identifies the issue is not about the code itself, it's about data. Because during this period, there's no crossover of the moving average lines, so we do not have a clear buying or selling signal. So after several rounds of questioning and answering, I cannot get a successful result. So let's go to the right hand side. Now this time let's try the results provided by Canvas, because I believe there should be a crossover in the dataset. The problem is that in the previous code it cannot identify. Let's see this one. Okay, so the Canvas code, first of all, it directly outputs several timestamp when there is a signal, and in general it looks more direct than the previous code version provided by 4o model. Now let's see. Because now we do not have error to debug, let's try to ask Canvas to improve the code. Can you improve the code to provide more explanation and show detailed data? So it will go to review the code line by line and change it. You see, it's a dynamic process, and eventually the final code will be provided on the same interface. You do not need to check another chat result, it is always here. So it's dynamically updating. And when you choose a specific block, you can ask ChatGPT. Okay, and you can ask it to change or explain. So the result will be presented again by changing the code line by line. Let's try this code to see if it gives us additional results. I think the package we do not need to install again, so I'm going to put it in manual. Let's run the code. Okay, so now provide me additional statistical information about the privacy function and the process of calculating the different metrics in the training perspective, then plot what's on the previous one, and now you can see the training volume under these charts. And I see a signal, the description, for example, this was cell and looks good, and the data calculating indicator. Yeah, everything looks alright. And also there's a comment here. This does not mean that the Canvas model is better than the phone. It depends on the use case. But the use case that I'm presenting right now, Canvas could give a zero shot as the result, and the phone model cannot provide the zero shot results, as you can see here. So for this scenario, I just you to try and to understand which model is the best for you. And of course, on the hand side, Canvas version, you don't need to be worried about the model to forget some content. Because it will always go through code line by line, and you do not need to worry for it. We already have a back and forth 50 round chat, and maybe some of the information is missing. So for coding purpose, at this moment, I think Canvas is better. But if you want a conversational style, it is suggested to go back to full model, because you can see there is a structured conversation. You can also see both the code and the textual output together. Now, after we zoom out of the code index of the Canvas model, you can see the textual information is very limited because all the change has already been applied inside of the code block. And for the full model, you can see that the code is always with the textual information. Case number 11, writing. Now I'm going to use the chain of thought model. It's called O1 preview with the Canvas to write a catchy song. I'm choosing this use case instead of the coding, because coding task for preview always involving a complicated thinking process. For a specific code block, it will take a lot of time to debug. Of course, you can try. But now I want to highlight is that the preview O1 preview model is going to think more than the other. And for the Canvas model, you can change the part you want dynamically. So let's try it out. So I'm going to say, write a catchy children song about weather. Okay, and we prompt both models. You see the left-hand side is goes into the thinking process two-step, right? Writing lyrics and crafting the melody. And you can see it is well written. On the side, we can see there is a verse and chorus almost similar, but the right-hand side seems each line shorter. So for left hand side, see the type of the steps give you results. Right hand side, it gives you results directly. So if I want to change part of the text definition, I can go back to this part. Say take this part. And in the interface, you can see this part already has been changed to a line. Or I want to into rewrite the song beginning to the end. And go to preview model, change part of this, say change for conversion. Thinking verse celebrity expression. You see verse on the model. You see this. And you see verse for the longer. So let's see make no shorter verse. So some task for but your project seriously is that you can preview model give share of your project either to application or design website and so on. But for the Canvas, you will see it for like a code. Like writing, it will be since if we go to the detail of pre-built project, it will involve a lot of steps. If you're interested, just comment in the future, I will give you bugs. At this moment, I just want to let you know the characteristics of the two models, so you have a better sense. Case number 12. Now we're going to get the case of using ChatGPT as a list compiler. So for example, now I'm going to make a shopping list of 1 kilo eggplant, 1 kilo rice, 1 kilo beef, 2 kilo apple, 1 kilo 1.5 kilo